In this video, we are going to go through the security information and event management module that is a part of the SOC Level 1 pathway of TryHackMe. And inside of this video, we're going to go through the introduction to SIEM and what SIEMs are. We're going to do the investigating with ElasticStack, also known as ELK 101. Then there's an exercise called the ItsyBitsy exercise, which is basically a practical exercise using Kibana and ElasticStack. And then we're going to go over the basics of Splunk, incident handling with Splunk, investigating with Splunk, and then another practical exercise called Benign, which is going to be using Splunk. So this is the outline of today's video. This video is sponsored by SurfShark, which is an all-in-one security solution that includes an antivirus and VPN software for unlimited devices. So you can secure unlimited devices, unlimited data, and it costs 7 cents per day, which ends up being $2.20 per month. And for that, you get access to literally one of the best security appliances and security softwares that's on the market today. And you can get access to that price in the description link that is available below. Now, without further ado, let's jump into the contents of this video.
All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And today we are going to go into an introduction to SIEM software, which is security information and event management. And this is a very big one, especially if you're studying to become a security analyst, SOC analyst, anybody on the blue team side, on the defensive security side. So I'm very excited about this one. This is one of the free rooms that's available inside of TryHackMe. So feel free to go ahead and get yourself a subscription, a membership to TryHackMe. There's a link in the description below. And if you wanted to upgrade your subscription, you can also use that link to get a discount on your subscription. The intro to SIEM room is a part of the security information and event management module that's a part of the SOC Level 1 pathway for TryHackMe. And we just started this. We wrapped the endpoint security monitoring, and we are jumping into security information and event management. And as you can see, there's a few cool little tools over here, including a really popular one, which is called Splunk. And we're going to be working with Splunk pretty closely. And I'm really excited about this one because this is a very important module for us to complete. So if you learn anything from this room and if you learn anything from this channel, I humbly invite you to like, subscribe, and turn on that notification bell, and even drop a comment because number one, it helps the YouTube algorithm find us, and it gives us a little bit more reach so that we can grow the community and grow the channel. But more importantly, if you subscribe and turn on the notification, you'll get notified the next time a video comes out. And if you're studying to become a security analyst or studying to become an ethical hacker, all of these videos will be applicable to you, and you can learn a lot from them, and you can grow and just have a lot of good information to assist you as you do other studies and so on and so forth. So without further ado, let's get into the introduction of the room. What is a SIEM? So it stands for Security Information and Event Management System, and it's a tool that collects data from various endpoints and network devices across your network, stores them in a centralized place, and performs a correlation on them. Basically scans all of these logs to see if there's anything wrong or if anything out of the ordinary. And so we're going to go into the basic concepts of this, which is what is it and what it does, why do we need it, what is network visibility, what are log sources, and how is a log ingestion done, and what are the capabilities that a SIEM provides. So this is a really big one. I'm really excited about this entire module. And the first question is, what does it stand for? And there's the answer: Information and Event Management System, Security Information and Event Management. It's like a mouthful. That's why the acronym is pretty awesome. But then there's freaking so many acronyms inside cybersecurity that it sometimes becomes very tough to keep track of everything. So let's talk about network visibility through a SIEM. Before explaining the importance of a SIEM, we need to understand why it's critical to have better visibility of everything going on in a network. The image below is an example of a very simple network that has multiple Linux and Windows-based endpoints, one data server, and one website. Each component communicates with the other to access the internet through a router, so on and so forth. So we have the router, we have the internet, there's a web server, we have 50 Windows workstations, 20 Linux workstations, and then we have our data server. So as we know, each network component can have one or more log sources generating a bunch of different logs. One example could be setting up a sysmon log with Windows event log to have better visibility of a Windows endpoint. And we can divide that network log sources into two logical parts. You have the host-centric log sources, and then you have network-centric log sources. And host-centric, as the name implies, is to the host. So it could be used by OS query. We just did a video on that. It could be used by Windows events logs, syslog, a bunch of different things. And it lists things like a user accessing a certain file that they shouldn't, for example, or a user attempting to authenticate and they fail multiple times or something. A process execution activity, process adding, editing, deleting a registry key or a value, PowerShell execution. A lot of these things are host-centric and they have to do with an individual operating system. The network-centric stuff is things trying to connect between the network through different protocols and anomalies that may show up, or specific activities, behavioral patterns that just are not good to see, and you're like, oh, what's going on here, right? So when hosts communicate with each other via the internet or just directly, and they elicit some kind of network-based protocol, SSH, VPN, HTTP or PPS, FTP, so many different things, so many protocols that exist, right? So an SSH connection could be a red flag, and a file being accessed via FTP, file transfer protocol, web traffic, user accessing a company's resources through VPN, network file sharing activity. All of these things could potentially be events that we want to look at. So the importance of a SIEM is that it combines all of that, and it does all of that in one place. This is very, very, very crucial. So if you've gone through all of the individual rooms that we've done, and you looked at all of the individual tools that we've used, you would really understand the magnificence and the power of a SIEM, because and this image is pretty iconic. Like it's a great way to describe what it does. So you collect the data from a bunch of different sources, you aggregate data, and then you discover and detect threats, and then you identify breaches and investigate the alerts. And all of this is done in one location. So the analyst doesn't have to go back and forth to a million different things. They could just be in one place, and then they can manage everything from that one place. This happens real time. It alerts against abnormal activities or anomalies. There's 24/7 monitoring, protection against the latest threats through early detection, data insights and visualization, ability to investigate past incidents, and then you can combine all of this through an API and connect it to other automation and auto remediation services, which turns into a SOAR. So a SOAR is kind of like the next step of a SIEM, and it uses automation to auto remediate a lot of things. And we'll probably talk about that at some point as well. So is registry related activity host centric or network centric? And I'm going to say host centric, because it is a part of the host, the registry. And a VPN, a virtual private network, as the name implies, is network centric. And we got that. So just like that, we have been able to complete our network visibility. So let's talk about log sources and log ingestion. Log sources and ingestion. So every device in a network generates some kind of log, whatever the activity is performed and whenever it is, like somebody visiting a website, connecting to SSH, a bunch of stuff, right? So Windows machine looks at all of these things inside something called the event viewer, but then you can also do a lot of commands through PowerShell or the command line using get win event or things of a similar nature. And this is the Windows version of a SIEM, I would say, but it doesn't do all the things that a SIEM does. It's the graphical user version of running through all of these You see all of these things on the left side right here? These are all different programs and operations inside a Windows machine that create logs and events, right? Then in a Linux workstation, it is not as user-friendly because there is no visual interface like that. So you'll have logs being done inside different folders and directories. So you have the log for HTTP, for cron, for authentication, security, and kernel, stuff like that. And this is what it will look like on a Linux version, right? So it's time-stamped and it shows you details on it, but it's not as user-friendly. It's just line after line after line of items and notifications. And then you have the web server example, and this is an Apache log, which is very similar to the Linux logs. It's line by line, but it deals with IP addresses and protocols and stuff like that. So it shows you this person, this particular case, there was a GET request made on this place, and there was a success. And in this particular case, there was another GET request, and there was success. And so that's kind of what that looks like. Log ingestion is when you take a bunch of logs and you put it inside the SIEM, and the SIEM ingests all of those logs for you. So you have the agent or the endpoint that ends up forwarding the information. So these solutions provide a lightweight tool called Agent. It's called a forwarder by Splunk, and then we just did the Wazoo room that was actually called an agent. But it's basically, it acts the same way. It forwards the information to the server that is ingesting all of those files, and it gets installed, the agent gets installed in the endpoint individually, and then it captures all the logs and sends it to the SIEM server. And then you have the syslog. It's a widely used protocol to collect data from various systems like web servers, so on and so forth, and all of that can be sent. And then you could do manual upload, that some SIEM solutions allow you to upload log files manually, and then you can of course forward ports to the SIEM so that it can listen on a certain port and start logging activity that way. And so an example of how Splunk provides various methods is this. You can upload, you can monitor, you can forward from a port, and just like that, you can have your log information in here. So in which location in a Linux environment are HTTP logs stored? And that is this wonderful thing right here called the verilog HTTPD. And then we can go and place that here. Why use a SIEM? It's used to provide correlation on the collected data and detect threats. Once a threat is detected, or something, a certain threshold or anything is crossed, an alert pops up. And this enables the analyst to take actions that's necessary to investigate further or stop what's happening from happening. And it plays a very important role in cybersecurity and helps detect and protect against the latest threats in a timely manner. So it's very important. I hope you understand this. Like, if you've done any kind of log analysis and if you've spent any time in the security world, you can understand and appreciate the power of a SIEM and the role that it plays. So it's a major component of the SOC Center, so the Security Operations Center. And it starts by collecting logs and examining everything. We've already kind of gone through all that. And then what it can do is correlate between events from different log sources, because sometimes it's not just one log source or one network instrument that we need to kind of analyze to see if something bad is happening. It could be across multiple logs, across multiple instruments or devices inside the network, and it could be across different timelines and certain things that a human being will miss, right? That's kind of the idea here. And it provides visibility on the host-centric and network-centric activities. It allows analysts to investigate and respond timely, hunt for threats that are not detected by the rules that are in the place, because it can pull from rules from a bunch of different sources, from common vulnerabilities, from MITRE, all of these different places, right? So this is the Security Operations Center as an example. And then there's a lot of stuff that's going on here. And it's kind of a rotating, spinning wheel, as we can say. Reporting, ticketing, log collection, knowledge base, research development, aggregation, threat intelligence, and the security information and event management. And they all go hand in hand. So the SIEM creates reports, which ends up being turned into a ticket, collects a log, and then it gets added to the knowledge base of the SOC Center. It goes into research and development, aggregation and collection, threat intelligence, and then again, and all of these things can also be done inside the SIEM. Like all of this can be done inside the SIEM. It can create reports and tickets, collect logs, establish a knowledge base, research and development, aggregate, threat intelligence. All of this is done inside the SIEM. And the more you have it running on your network, the more of a baseline that it'll establish, the more of a knowledge base it establishes, and so on and so forth. So it just becomes more and more powerful the more it's running. And I mean, you gotta appreciate that. You gotta love that. So what happens now for the SOC analyst after the SIEM does all of those things is that you just monitor and investigate, identify false positives. So just in case a red flag goes up, it's like, oh, that's okay, that's not bad. Tuning rules which are caused using noise or false positives to fine tune it and make it even better at detecting bad things. Reporting and compliance, identifying blind spots, so on and so forth. So when the SIEM or the software ends up doing so much of the work, the analyst can actually sit there and focus on, oh, okay, this is what we should actually do, this is what we should detect, so on and so forth. So it makes the job of a security analyst much easier, and you gotta love that. You gotta appreciate that. So let's jump into analyzing logs and alerts. So once we have our logs, we can look at the dashboard of a SIEM essentially, and it'll show you a lot of things just on the dashboard. And then from there, you can further investigate if you need to, right? So this is some of the stuff that shows up on a standard dashboard. And this is QRadar's dashboard that we see below. And you have alert highlights, system notification, health alert, list of failed login attempts, events ingested, rules triggered, top domains visited, and all of this stuff is literally right here. So you can see everything on one section, and the most important stuff ends up being on the section. And of course, you can modify your dashboard to show you the individual categories that are most relevant to you. And now you have correlation rules, which are an important role in timely detection of threats, allowing analysts to take action on time. So correlation rules are pretty much logical expressions that are said to be triggered, and a few examples are this. So if a user gets 5 failed login attempts in 10 seconds, raise this alert. If a login is successful after multiple failed login attempts, raise this alert. A rule is set to alert every time a user plugs in a USB if USB is restricted as the company policy. If outbound traffic is bigger than 25 megabytes, raise an alert just to potential data exfiltration, or if consumption of a system is higher than a certain capacity. It could be somebody's using your system to mine something. Crypto mining is actually a really big deal apparently, and people will hack into big systems that are fully capable to mine crypto. It's pretty awesome when you think about it. It's awesome on both ends. It's like on the idea of the hacker where it's like, dude, that's kind of genius. If you don't have the capabilities on your computer, you just hack into a really powerful computer and use that computer to mine crypto. Like, that's so great. So use case number 1, adversaries tend to remove logs during post-exploitation phase to remove their tracks. A unique event ID is 104 every time a user tries to remove or clear event logs. To create a rule based on this activity, we can set the following condition. And so if the log source is win-event log and the event ID is 104, trigger an alert that the log has been cleared. Case number 2 is adversaries use commands like who am I to escalate privileges, or after they've done escalation, just to see who they are. If they want to see if they're root, they'll be like, oh, okay, I'm root now, right? The following fields will be helpful to include the rule. So log source would be wherever is capturing the log, the event ID associated with process execution, in this case 4688, and then the process name, which process name will be helpful to include in the rule. So if the log is win event log and the event code is 4688 and new process name contains who am I, then trigger an alert that says who am I command execution detected, right? So that's kind of a gist of what you can do, but obviously you can do so much more. So in the previous task, the importance of field value pairs was discussed. Correlation rules keep an eye on the values of certain fields getting triggered and that's the reason why it's important to have normalized logs ingested. So alert investigation. When monitoring a SIEM, we spend most of our time on dashboards as it shows various key details about the framework in a summary. Once an alert is triggered, the event flow associated with that alert is examined and the rule is checked to see which conditions are met based on the investigation. If we examine that it's a true or false positive, some of those actions can be performed. So alert is a false alarm, alert is a true positive, contact the asset owner to inquire about the activity, suspicious activity is confirmed, isolate, and block the suspicious IP. This is just a basic flow of activities. If it's a false alarm, we just tune it so that it doesn't register those false alarms anymore. If it's a true positive, we investigate. We contact the asset owner, so whoever the user of that computer is or manager of the server. Suspicious activity is actually confirmed. You isolate the infected host, meaning remove it from the network, unplug all internet cables or turn off Wi-Fi, whatever it is, remove it and isolate it, and then block the suspicious IP that was attacking you. Question here is which event ID is generated when a log is removed, and that is 104. And then what type of alert may require tuning, and that would be a false alarm. And just like that, we are done, and now we can jump into the lab work, which should be pretty exciting. All right, so we click our little view site and this thing pops up and we're looking at a SIEM dashboard as it seems. And so we're just gonna kind of run through these questions just to see what we can find. So the first one is click on the start suspicious activity. Which process caused the alert? This process is well-known mining software, Kudo Miner. So I mean, it's already here. So kudominer.com might just be the answer. I'm gonna copy that and paste that over here and see if that's the actual answer. Okay, it's not the answer. I was about to say, like, what? Oh, we're probably looking for an executable. Okay, fair enough. So we're gonna look for Kudo Miner. And so let's see what we can find here. We're gonna start the activity and it's gonna show some things. Start suspicious activity and Kudo Miner. There you go, it pops up. Potential crypto miner activity observed. Find and click on the triggered event to show the details. So first, it's kudominer.exe. That's what the actual answer is, kudominer.exe. And it's funny because we were just talking about mining, right? Isn't that interesting how everything just plays together? So kudominer, so now find the event, and this is the event, so let's click on it. And so look through the event log to find the event that triggered the alert. So we're gonna, this is our full event log. So we have process creation is everything, event ID is everything, info, process ID, Windows event logs, audit success, event log, hostname admin. So this is where we start to see some changes. The usernames are all changed. And then now we have some interesting stuff. So Python executable has been running, Java WS, Microsoft Edge, QuickTime, and QW. That's, oh, Kudo Miner right here. So this is the one on Chris's machine. So Chris Fort, being the username, had Kudo Miner running. So, okay, click on the button below to show the rule that triggered the event. So find the event that caused the alert. What was responsible for the process execution? Which user was responsible? And that is Chris Fort. So Chris.Fort, whoops, okay. I misspelled his name and it still gave me a right answer. So what is the host name of the suspected user? So the host name, did we already get past that part? I feel like we did. Okay, fine. So the rule that alerted us was potential crypto miner if the event ID is 4688 and the log source is event log and process name has miner in it in some capacity or crypt in it in some capacity, alert us. And so that was it. So now how would you like to action this rule? I'm going to say that this is a true positive because that's a big deal. And so this is our flag for this exercise, which is going to go at the very end here, but we're still missing some information. So we got to go find the intro. So is there a way that I can restart this thing? because I need some information. Okay, here we go. Start activity. And then we're going to start the traffic one more time. And then there's going to be CUDA miner. We're going to click on that damn thing. And voila. And we're going to go down here. Okay, I'll find the event. Give me a second. So it's Chris Fort. And who do we want? We need the host name of the suspected user. So we're going to go to the category that says host name. And it's HR_02. So that is the host name. And there's that. And examine the rule and the suspicious process. Which term matched the rule that caused the alert? Both of the things, I think, caused it, right? So it was either crypt or miner, because the name of it is kudo miner. Actually, no, miner is what caused it. So we're going to be miner. And then the best option that represents the event, choose from the following. It's going to be a true positive. And that is our final answer. And we got our flag. So lovely, lovely, lovely job. Moving on. In conclusion, we have covered what a SIEM is, what it does, and the visibility that it provides. We can learn much more in the following rooms, which is the and challenges. So we have the Junior SOC Analyst, Splunk 101 and 201, which is a part of the path that we're on right now, I think. Probably not, actually. I think it goes even further than that. So Splunk 101, 201, there's Benign, which is definitely on this path. It's at the bottom right here. Investigating with Splunk, that we saw right here. And then we have investigating with Elk, which is not, oh, it is right here. Investigating with Elk is the very next thing. And then ItsyBitsy, which is also in this path. So most of these things are in the current module that we're on right now. So that's going to be exciting to do. And just like that, we have wrapped this room. So very, very exciting. I really, I was waiting to get to this part because, I went through all the introductory stuff and I'm like, I really want to just get to the meat and bones of this thing, or the meat and potatoes, or whatever it's called. So I'm excited. I'm excited that we finally made it, and we just wrapped the introduction to SIEM. If you found any value in this video, if you learned anything from this video, please go ahead and like, subscribe, share, comment, turn on the notification bell, all that good stuff. When you do that, two things happen. Number one, the YouTube algorithm finds our channel and gives us more reach so that we can grow the community and help more people on their journey to become a cybersecurity analyst or an ethical hacker. But then the more important thing is that when you subscribe and turn on that notification bell, you get notified the next time that a video comes out. And if you're starting to become a security analyst or an ethical hacker, then you actually can use a lot of these videos, if not all of these videos, because this is directly related to the task at hand to become a security analyst and an ethical hacker. So it would mean the world to me if you would like, subscribe, and do all that stuff, but I think it's also very useful for you if you did do that. So it would be a great win-win, in my opinion. That's all I'm trying to say. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker, and we just wrapped the introduction to SIEM. Peace, love, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next room. Later. Hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers. And in today's video, we're going to go through investigating with Elk, which is something that I've actually never even heard of before. So I'm pretty excited about this one. This is through TryHackMe. We are on the pathway for security information and event management, or excuse me, we're on the SOC Level 1 pathway, and we're in the module for security information and event management. And we did the introduction to SIEM in the last video, and in this video, we're going to go into investigating with Elk. So this should be exciting. We're about to learn some cool things, I think. Before we get started on the room, just want a quick reminder, if you learn anything from me, if you've learned anything from my channel, or if you're gonna learn, or if you like these videos or anything of the sort, I invite you to like, subscribe, turn on the notification bell, and of course, leave a comment, because two things happen when you do that. Number one, the YouTube algorithm helps find our channel easier, we get more reach, we expand the community, and we can bring more people to actually help them on their path to become a security analyst and an ethical hacker. But number two, the more important thing, is that if you're studying to become a security analyst or ethical hacker, then when you subscribe and turn on that notification bell, that actually helps you, because you get notified the next time a video comes out. And the only thing that I talk about on this channel is cybersecurity analysis and ethical hacking. So that's all we talk about here. And that's basically the topic of all of the videos that we do. And I do multiple posts a day sometimes, but at the very least, I do one post a day. I'm trying to get into a flow where I do at least 2 posts a day, and then we just keep going up from there. So it would be a win-win situation. You would be helping yourself, and you would be helping grow the community and grow the channel. So I invite you to like, subscribe, share, turn on notification bell, and drop a comment just to say hi or ask a question, whatever you want to. And from there, we'll get everything else going. So without further ado, let's jump into the introduction of the room. All right, in this room, we're going to learn how to utilize the Kibana interface to search, filter, and create visualizations and dashboards while investigating VPN logs for anomalies. It's also going to cover a brief overview of ElasticStack components and how they look and work together. So we're going to perform searches, apply a filter, save search, create visualizations, investigate VPN logs, and all of that stuff that's super fun to nerds like us. So let's talk about incident handling, and it's a specific scenario. So we're going to look at an incident handling scenario here. Alrighty, here's the incident. A US-based company, CyberT, has been monitoring the VPN logs of the employees, and the SOC team detected some anomalies in the activities. Our task as SOC analyst is to examine the logs for January 2022 and identify the anomalies. Some of the key points to note are: all VPN logs are being ingested into the index VPN connections. The index contains VPN logs for January 22. A user, Johnny Brown, was terminated on January 1st. I mean, I can already tell that he's the culprit here. And we observed failed connection attempts against some users that need to be investigated. So Johnny seems to be doing some hacktivities, some things that are not good. So I think this is the dashboard of the tool that we're going to end up using. And we're looking for VPN connections specifically. And we're looking at January to February. And we have 2,861 hits. So that's a lot of stuff to sort through. So let's see here. We're going to first look at the overview of ElasticStack and then Kibana. And then we're going to go into the rest of the stuff. ElasticStack is the collection of different open source components linked together to help users take the data from any source and perform search, analyze, visualize the data in real time. So we have Elasticsearch, Logstash, Beats, and Kibana. That's what ElasticStack probably does. And so Elasticsearch is a full text search and analytics engine used to store JSON format documents. It's an important component used to store, analyze, perform correlation on the data. And Elasticsearch supports RESTful API. Logstash is a data processing engine used to take the data from different sources, apply a filter, normalize it, and then send it to the destination, which could be Kibana or a listening port. And configuration file is divided into 3 parts. You have the input part, the filter part, and the output part. So the input part is where the user defines the source that the data is going to be coming from. The filter part is where the user specifies the filter option to normalize the log ingested, and then support many filter plugins, obviously. The output is where the user wants the filter data to be sent. And it could be a listening port, it could be another interface, so on and so forth. So that's what Logstash is. Then we have Beats, which is a host-based agent known as data shippers that is used to ship transfer data from the endpoints to Elasticsearch. Each beat is a single purpose agent that sends specific data to the Elasticsearch. All available beats are shown below. So file beat, metric beat, packet beat, winlog beat, audit beat, heartbeat, function beat, bunch of beats. And then we have Kibana. Kibana is a web-based data visualization that works with Elasticsearch to analyze, investigate, visualize the data stream, and allows users to create multiple visualizations and dashboards for better visibility. More on Kibana in the following tasks. And so we got Beats, goes into Logstash, goes into Elasticsearch, which could be fed into Kibana, and the Kibana feeds back into Elasticsearch, and it just goes back and forth like this over here. And then so data collection agent is B, data input filter process output is Logstash, index and store data is Elastic, and Kibana analyzes and visualizes. So Logstash is used to visualize the data. That would be nay. I'm going to say no to that. And ElasticStack supports all data formats apart from JSON. And I want to say, is that a yes? Let's see, ElasticStack, where is it? Elasticsearch, ElasticStack. Oh no, I see. So it says it supports all apart from JSON, and that is also no, because it does support JSON. Okay, very good. So we got that. And now we are going to go into the Kibana overview. Kibana, in this room, we're going to explore the different features while investigating the VPN. It's an integral component of ElasticStack that's used to display, visualize, and search logs. And we're going to look over the Discover tab, visualization, and dashboard. So if you've ever seen a log before, it's really not fun to look at a log. It's very freaking overwhelming, especially if it's a big ass log that has thousands of lines of events that has been collected. So it's really not fun, and you like things like this, something that visualizes everything for you and it organizes it, and it's visually pleasing compared to a freaking log file. But then you can do a lot of really neat filters, like just a timeline filter. Just to be able to filter things by time is super useful. But then you can add a bunch of different types of fields and filters to it, and it's just so much more useful. So before going backward, before moving forward, we're going to deploy the machine or start the attack box, which I have already done. So I'm very excited about that. And when we do deploy our virtual machine and start the attack box, we're going to go into this IP address, and it's going to take us a few minutes to start. And then our username and password is going to be this. So from here, this is where the machine would be, that start machine. And then at the very, very top, there's a blue button. Before it says start attack box, but now it says show split view because the attack box has already been started. So first we're going to go into here, and then we're going to log in to our information here. We're going to go into the browser and log in, and then from there we're going to do the rest of the task. All right, so our machine has loaded. It took about, like it said, it took about 3 to 5 minutes to actually load this thing. And we went into our Firefox browser. We went into the IP address that they gave us and logged in with the information that they told us to use. So just to make this a little bit more user-friendly, I'm going to open this up in a new tab. So we have full screen access. And then from here, we're just going to go and answer the rest of our questions here. So let's talk about the Discover tab of Kibana. I think that's basically what we're using, right? Yeah, we're going to use the Discover tab of Kibana. All right, so the Discover tab is where analysts spend most of their time. So it shows the ingested logs, known as documents, the search bar, normalized fields, a bunch of things. We can search for logs, investigate anomalies, apply filters based on search term or time period. And this is kind of what it looks like. I mean, at first glance, because of all these different red numbers here, it kind of seems a little bit crazy. But so this is the actual individual item that is showing up in all the timestamps and everything that's attached to it. Number 2 would be the popular fields that you can filter by. Number 3 is the VPN connections or anything else that you want to look at specifically as far as logs are concerned. Number 4 is the search bar. Number 5 is the date or the calendar for which that we can do the range of the time. Number 6 are going to be the graphs that show the number of hits and the frequency and what days. For example, this particular day seems to be high activity. Number 7 is the inspect button up here. 8 is the discover tab, and we can switch between different views with that. And then 9 is adding filters. So this is kind of what it looks like. So the logs or the document is shown as a single document containing information about the event. It shows the fields and values found in that document. The fields pane, left pane of the section right here, this whole thing right here. This is the interface, shows the list of the fields parsed from the logs. We can click on any field to add the field as a filter or remove it from the search. There's the index pattern, shows the index pattern that was available from the list, search bar, time filter, time interval, all of that stuff we already know. And the top bar contains various options to save, search, open to saved, or share, or so on and so forth. So this is the time filter, very, very basic. Quick select is under that little tab where we just click it and it shows you what you want. I mean, this you should already be familiar with because so many different applications use this. This is the timeline, and we can see based on just the number of activity. So the count at the top displays the number of document events that are found during that selected time, and then which specific days or parts of that entire timeline were the busiest. Then you have the index pattern, and in this particular situation, it's the VPN connections that we're interested in. But there's a few different things based on what you have loaded that you could probably go through and try to find and look at. Then you have the left panel fields, which is right here. We have the selected fields and the available fields that we can search from. And then we have the filter option. So you click on something and then you can add it as a filter. So you can do the source IP and is inside the filter, and it's this, right? So that's basically it. So you can see that in the selected field, you can do source IP. This was the value of the source IP, and then you can go ahead and use that to be one of your filters. Now then another one that they're going to add is the destination, right? And they're going to say source state is New York, for example, or is not New York, whatever they wanted to say, right? So that's how you build filters, and it's pretty intuitive, pretty easy to understand. And we can even go by Michigan, I guess, right? So there's a lot of things that you can do here. So from here, we're going to be able to create a table, and the documents are shown in raw form. We can click on any document and select important fields to create a table showing only those fields. So for example, the field and the value of the field. And you can show a table that way. And that is pretty much it. So don't forget to save the table format once it's created. It'll show the same fields every time that the user logs into the dashboard. So now we're going to go and run this exercise and see what answers we can find over here, which is freaking exciting. I get excited about very basic things, as you can tell. So I am going to open this up in a different window just so I can access it a little bit easier, and we'll run into it. We'll run it. All right, when we first load Kibana, this is what it looks like over here. So we got to click on this left side over here and go into the Discover tab, because that's what we want to be using to answer most of our questions right now. And the first question is select the indexed VPN connections and filter from December 31st to February 2nd. How many hits are returned? So we're going to be filtering from December 31st, which is going to be right here. So we're going to go here and I'm going to click on that, and I'm going to do absolute, and I'm going to go December, and it's December 31st, 2021. So that's the other thing. So we're going to go from there and we're going to choose December 31st, 2021, and then here we're going to do absolute again. We're going to go to February of 2021, and it's going to be February 2nd, 2021, and we're going to do that. So we're going to run these two dates, and then we're going to do update. My bad, it was supposed to be December 31st, 2021 and February 2nd, 2022. Obviously, it can't go backwards. So, okay, so now we have this, and it says how many hits were generated, and the answer is right there, 2,861. So 2861 is going to be the answer for that. Which IP address has the max number of connections? So let's try to find that. So if we click on the source IP, it just says right here that the top 5 values are this thing, and it shows that out of all of these hits, 3.2% of them belongs to this particular IP address. So I'm just going to copy that one and see if this is actually the answer that we want. And it is. So just like that, very easy to find. Which user is responsible for the max traffic? So let's see inside our fields right here, there's a username. And so if we go over here, there's, for the max traffic, there's this guy named James that has 4% of the traffic, and that's actually the answer. So now what we want to do is we want to create a table with the fields IP, username, source country, and save it. So let's do that. So I think one way that we could do this is we could just click on the field itself and then press this little plus button, and it would add it as a column to our table. So there we go. So what we want is the IP, username, and source country. So we added username, and we're going to add IP, and we also want source country. And so that now it's all over here. And now we can zoom out of this, and now we have our table right here. So the next question says, apply the filter on the username Amanda, and which source IP has the max hits. So now what we're going to do is we're going to add a filter, and we're going to say that the filter itself is the username. So where is it? Right there, username. The username is, and it's Amanda with an E, so E-M-A, there she is, Amanda. And there we go. And just like that, we're going to save it, and then it should say how many hits. So we got 56 hits for Amanda, and it says which source IP has the maximum number of hits. So here's another one that's good. So we're going to go on source IP here and click on source IP, and the maximum number of hits for Amanda is this source IP. So we're going to copy that source IP and paste it here, and just like that, that's the right answer. So on January 11th, which IP caused the spike observed in the time chart? So if we look back over here and we look at the time right here, this is January 24th, January 23rd, 22nd, and we can come here. This is January 16th. So where is it? January 7th, January 14th. So I think I need to remove this filter because that is now messing with our data. So there it is. That's the January 11th data. So the question now says, which IP caused the spike in the time chart on January 11th? And we have this over here. So if we look at it, let's make sure that we actually have the right thing. I feel like I may have kind of messed that up. So if I click back, okay, there we go. We have January 11th, 280, and we want to see which IP caused the spike on this day. So how could we check that out? So I'm just going to, I just clicked on January 11th one more time, and I'm going to go and sort this. So we want to sort in, I guess, descending, just to see the number of IP. I mean, this is literally the IP that shows up the most. So it's the 172.201.60.191. That seems to be the IP address. So we're going to go here and paste that in there. And I think since we already did that, so if I just go to source IP again and click on this, and it should show me, yeah, there you go. It actually shows the values as well. So without having to scroll through that, we could just look at this and it shows us the top IPs. So now, last question. How many connections were observed from IP 238 excluding the New York State? So we're going to create a filter for ourselves again. And from here, we're going to go back and we want to look at all of the dates one more time. So we're going to go to 2021. December, and it's going to be December 31st, and it's going to go all the way to 2022, February, and I think it was February 2nd, right? So if I update this, yeah, 2861, so there you go. And so now I want to add a new filter here, and it's going to be, the first filter is the IP address. So the IP is going to be source IP is, and the value is 238, 163, 231, 224. So that's the first one, and it excludes the state of New York. So we're going to go here, and the state So state, let's go find state, and there it is. And we're gonna say the state is not the state of New York. So just click on that and save that. And now we have our data. So now it says how many connections were observed in this time, and the answer is 48. And that is indeed the right answer. And just like that, we have all of our questions answered from this. And this is, I mean, you gotta admit, that was freaking super easy. That was really, really easy to do. Very, very excited about this Kibana tool. I love this SIEM pathway. I hate looking at log files. Okay, I cannot stand it. And so the fact that something like this exists, and we're getting into all the juicy stuff, all the good stuff. I'm so excited about this. You don't understand. Okay, moving on. We're gonna look at the KQL overview. KQL stands for the Kibana query language, and it's a search query language used to search logs and documents. Apart from the KQL language, Kibana also supports Lucene query language, and we can disable the KQL query as shown. So right here in the search bar, you could literally click on that little thing at the end of it, and then you could turn it on or off. And so I'm guessing if it's off, it's gonna default to Lucene. If it's on, it's gonna be KQL. And so from here, we're going to explore the syntax. So free text search and then the field-based search. So if you want to look at something, for example, a simple term being security will return our documents that contain this term irrespective of the field. So it'll be everywhere. But if we look at the index, which includes VPN logs, one of the fields is source country, and it's the list of countries where the connection is originated as shown below. And so from here, we can search for United States, and it'll show, it's going to return all the logs that contain this term regardless of the place or the field. This search returned 2,304 hits. And now if we do United, it's not going to show anything because it's inside quotes, right? So it's searching for exactly that, and so it's not going to show anything. Then you have the wildcard. So it could be United wildcard, and it's not in quotes, and it's 2,304 again because everything has to do with United, but I'm guessing that will also show United Kingdom, you know what I mean? It could also show United Nations, right? So that's kind of what it's like. And then we have and, or, and then not, which are the various operators. So you could do United States or England, and it will show everything including United States and or England. And then you have the and operator, so United States and Virginia. And you have to have that in the source states. I don't know if you have to actually activate the field to be able to search for it like that, but it can show you that. So if it's United States and Virginia, then it'll only show 304 hits versus the number of hits that were previously there. And then you have the not operator, which is United States and not Florida. So everything that's in the US but not Florida, right? So it would show Virginia, Maine, Tennessee, Michigan, so on and so forth. And you have the field-based search, which would be the field and then the value, which is the syntax of this. So it would be source IP and then the value, and the username is Suleiman, and that would show a certain number of results, right? So explanation, we're telling Kibana to display all the documents with the field source IP containing that value and the username as Suleiman. Pretty standard, basic. So we're going to create a search query to filter out the logs from source country as the United States and show logs for the username or Albert, how many records were returned. So let's try to create a query for that. So the piece of that could be source country, could be one of the things right here, and we could do United States, right? And so we'll do and as our next piece. Username could be, what did they say? James and Albert, right? So James or Albert. So username would be James or username would be Albert. So let's see if this is the right one. So if we update this, we're going to get no results. So that can't be it. Oh, you know what? I'm going to delete these previous filters that we had here. There we go. That makes more sense. Okay, so in this case, we now have 161 hits. So let's see if that's right. And that is right. So that was a good query. So that's the query. Source country is United States and username James or username Albert, and it gives us 161 hits. Very good. So it says, as user Johnny Brown was terminated on January 1st, 2022, create a search query to determine how many times a VPN connection was observed after his termination. So now we're going to look at some other things right here. So let's see. We're going to do, there's an event time. So event time, and that's going to be, the event time is just going to be January. We're going to do, the format is January 1st, 2022. That's going to be the event time. And the type of the connection, or we're going to do and username will be Johnny Brown. Press enter. Let's see what we can find. Can't find results. So the event time, so maybe we can do this and press username Johnny Brown, see what shows up. And it's just one hit. So that's all we got. And it just so happens that it was January 7th. So create a launch query to determine how many times it was done after his termination. And the answer is 1. So all we had to do was just search for Johnny Brown. Johnny Brown. I don't know what you did, buddy, but you got terminated. Okay, so there is that. And now we can go into the create visualizations. Who doesn't love a good graph, right? So tables, pie charts, bar charts, a bunch of different types of visualizations can be created here. So the information, let's see how they're doing it. Or maybe we can, there's also a correlation option. And then we can also do a create table as we saw already. And then we have the save the lens visualization. So after creating visualizations, you can create and click on save, add the title. We can add the visualization to anything, click save and add it to the library when we're done. And then you can do all of that by creating the visualization specifically, right? So the way that can be done is that we can go and create a filter. We would add it over here, and it's going to be failed action, and then create a username and drop that. I see. So once you've done visualization, and I think this is inside the visualized library. So based on what this shows right here, we can just start adding things based on that visualization. And that's what it looks right here. So this is, you can also just go from the individual items right there and then click on visualize, and it will show you how to do it. So there's a lot of different things that you can do, and there's a lot of different options at the bottom for the visualization itself. So we can get to it in multiple different ways. We can actually just go to the visualize library manually and start creating and start adding items to it, or we can add things, or we can click on the filters and then just click on visualize. So which user was observed with the greatest number of failed attempts? So let's go here and then let's see if we can find something for the action, right? So we're looking for an action, and the action itself could be a bunch of different things. So we're going to first get rid of our username Johnny Brown and update our stuff so that it's back to 2861. And then the action that we want is tear down, build, and there's a bunch of different things. So first we're going to add a filter where the action would be failed attempts. So action is, and the option is failed. So action is failed. And then we're going to save that. And now we have that. And so we can click on username and visualize. just to get the hang of this visualization thing. And it's one user, so it's not a lot of different users that have been here, and that user is Simon. So let's go over here and add Simon to the list. And how many wrong VPN connection attempts were observed in January? So we can go back here and go to discover, and we can leave these things unchanged. That's fine. And the question is, one more time, is how many wrong VPN connection attempts were made in January? So the field that we want to look for was probably going to also be action. So I'm going to remove action, failed, and see if we can find anything else apart from that. So this time I just visualized the action filter, or the action field, and this is what it looked like. And we have failed attempts 274, and since we're in the connection log, the VPN connection log, I would assume that that's what it is. So the failed attempts is literally right there, and the answer actually is 274. So we got that, and that is indeed the right answer for that. And so now we can move on. So there you go, that's the right answer. And we can move on to creating a dashboard. And creating dashboards doesn't seem to have a specific task question for us. So I'm just going to mark it as complete. But essentially, we could just create custom dashboards. So we can go to the dashboard tab and create a new one, and then we can add from the library and save any visualized searches. We can add any other items accordingly on visualizations and save searches, items that are added, adjust them accordingly, and don't forget to save the dashboard after completing it. So that is as simple as going here, clicking on dashboard, and since we don't have a dashboard, we can create one from scratch, and you just create new, and then we can do, create visualization if we wanted to, and we can save the visualization. That's going to take too many steps, so I'm just going to go and add from the library and country with top traffic. That could be one of the things over here, right? And there you go. That's what it looks like when you just add it to the dashboard. And you have all types. So we can do a map, for example. It's unable to visualize the map. That's unfortunate. So there's that. What do we got? We got Canada, England. That's going to be all of our types over here. Let's see, we could do a log stream. Could we do that? There are nothing, so check to nothing to put in here on the log stream. And then anything under library, anything else that we can add under library. And there is nothing. There's only 4 types of things. Lens visualizations, one type, and we just remove that. So there's 4 types. I guess we would have to manually create them. Oops, I accidentally shrunk it down. I guess we would have to manually create our visualizations and all the different things that we want, but this is kind of where you can go to do it. If I would have saved the other visualizations that we had, we would have been able to also import them over here, but I didn't, and I kept canceling out and not saving. So that's, I guess, kind of the issue with that. But you can go to dashboard and you can create your own custom dashboard with visualizations using Elastic. So very, very cool tool. Overall, very cool experience to be able to use the ELK 101 room, which combines a few different things, which happens to be the ElasticStack overview. So we have all of these things that were combined to give us this wonderful thing right here through Elastic. So very, very cool tool, and we are now going to do the conclusion of this, which I don't think even requires one, so we could just read through it. We briefly explored the ELK components, and we learned how to search and query a log, apply filters, create visualizations, and how to investigate the VPN log. And just like that, we are now done with the Investigating with ELK 101 room. Alright, so if you learned anything from this video, if you got any tips out of it, if you found any use from it, and if you found anything from my channel that you found useful, one of the big things that I would very much love if you could do would be to like, subscribe, turn on the notification bell, and of course leave a comment. Any of those activities that you do will actually help the YouTube algorithm find us and give us a little bit more reach so that we can expand the community and grow the channel and do all those great things and help as many people as we can down this path of cybersecurity analysis and ethical hacking, security, all that stuff. So the second thing that's pretty useful when you do that is if you subscribe and turn on notification bell, you actually get notified the next time that a video comes out, and you will continue down this path with us. And if you're starting to become a security analyst, or if you're starting to become an ethical hacker, all of these videos will actually be very helpful to you directly, because that's literally all we talk about on this channel. So it would mean the world to me if you could like, subscribe, leave a comment, all that stuff. But I think it's also very useful for you if you did something like that. So it'd be a great win-win type of a situation. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And I hope you got value out of this video. I will definitely see you in the next one. Peace, love, and chicken grease. If no one else loves you, Hank loves you. I'll see you in the next room. Later. All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And in today's video, we are going to go through a challenge called ItsyBitsy. And it's a continuation of the ELK room that we did, the ELK room inside of the Security Information and Event Management module, the SIEM module inside of the SOC Level 1 pathway of TryHackMe. So we learned a lot of good stuff with investigating with ELK, and then now we're kind of left to our own vices to try to answer some of these questions and try to pull out some of these flags and all the good information here. So as you can tell, there's a chart and there's a scoreboard and all these things, and the difficulty of this room is apparently medium, so we're growing out of the beginner pathway and we're looking at some really cool information here. And this is, I don't really know how the scoreboard works or how they rank these things, because you got to answer the questions. I guess maybe they time you or however it is, but if you do it, and if you end up finishing it and getting the information, and of course, obviously, if you have a walkthrough like this, then you should be able to do it very quickly and very easily. So yeah, anyways, without further ado, before we jump into this room, I just want to kindly and humbly request if you could like, subscribe, turn on notification bell, comment, all that stuff. It would mean the world to me if you could do all of those things, because it does help the YouTube algorithm find our channel and give us a little bit more reach so that we can get a little bit more exposure to our community and help other people who are trying to study for cybersecurity analyst or ethical hacker, pen test plus, all that stuff. And I mean, more importantly, if you do subscribe and turn on that notification bell, you'll actually get notified the next time a video comes out. And if you're studying for cybersecurity analyst, pen test, ethical hacker, all that stuff, all these things actually apply to those tests, and they apply to your overall career pathway. So it's a win-win situation, in my opinion, if you actually do that. But if you don't, I mean, it's all good. The view even helps, and at the very least, hopefully you'll learn something down this path. So without further ado, let's jump into the introduction of this room, which basically says that we got to start the room machine and get the login taken care of. I clicked the machine when we started the video, so I'm going to give it a few more minutes before actually going and logging into this server IP, and then logging in with our username and password and getting in there to start answering these questions for these scenarios. So let it load, and then we'll come right back. All right, here we go. We are now inside of the ELK or Elastic portal right here, and our machine loaded and everything's all good and we're logged in. So now we're going to actually jump into some of these questions, and the premise is this, right? So during a normal SOC monitoring, analyst John observed that an alert on an IDS solution indicating a potential C2 communication from user Brown from the HR department, a suspicious file was accessed containing a malicious pattern, and a week-long HTTP connection log has been pulled to investigate. So Due to limited resources, only the connection logs could be pulled out and are ingested into the connection logs index inside of Kibana. So our task is to examine the network and try to find what the hell is going on, right? So the first question is how many events were returned for the month of March 2022. So if you remember, first thing we got to do is we got to click on this menu on the top left right here, this little hamburger menu, and then we're going to go to Discover. And Discover is going to load the connection logs automatically for us. And there's no search results because the filter, the time filter, is only showing the last 15 minutes. So we're going to do this. We're going to go here. We're going to do an absolute, go into 2022. And we need March. So we're going to go from March 1st of 2022. And then we're going to change this to also absolute. And we're going to do 2022, March, and March 31st. And so we update that. And now we actually have some data to go through. And the first question is how many hits were there? So it's, of course, 1482, which is the answer right there. Now, the next one is what is the IP address associated with the suspected user in the logs? So we're going to go look at that. And so what we want to do is we want to just click on one of these things. So we're going to do destination. Or actually, I'll do source first. I'll do source IP, and then I'll add using this little plus button. And then I will do destination IP, and I will add using the little plus button. And so a nice little feature of this, and all SIEMs are like this, so this is what I really like a lot. So if I click on source IP, it shows me the top values, right? And the overall assumption would be, okay, if it's a C2 command and control thing, maybe it's the thing that has the bulk of the traffic, but we literally only have 2 views. And a lot of this traffic is actually legitimate traffic. So let's click on one of the hosts, for example. So we're going to add host right here. And when you add the host, it shows you a bunch of information, right? So redirector, storage, Google API, and then more redirector stuff, Google API again, and just kind of like basic data that's gone through this delivery, Microsoft stuff. So all of these things are coming from the same IP address, the same source IP address. So if it's going to storage Google API, or if it's going to Microsoft, or if it's going to Adobe, you can't really assume that that's the malicious IP. And it's easy to assume because of the volume of the traffic. So the only other option would be this one. So 192.168.6564 or 6554, right? And so that actually ended up being the right answer when I ran this, right? Now the next question is, so the user's machine used a legit Windows binary to download a file from the C2 server. What is the name of the binary? And so we're going to click on, first we're going to filter the IP, right? So we're going to say add a filter, and then we're going to say that the source IP, so we're going to go find source IP. Let me find it real quick. There we go, source IP. The source IP is, and I want the 192.168.6554. That's going to be the one that I want to see. And when I do that, only 2 options come here. And so one interesting thing that we see right here is that the host is pastebin.com. And then what we want to see now, this is the other thing that's really cool. So since we've already filtered everything by that IP and we only have these 2 hits, anything else that we look at on the side right here is only going to have to do with these 2 hits. So now you can literally just kind of click through things and see what has loaded, right? So you have, obviously timestamp isn't really that important. Index we're already looking at. The method is probably going to be, a get method as well as a head method, meaning we want to see the header. And what else do we got over here? We got the request body length, we got MIME types, body length again, source port, status code, message, timestamp, UID, ooh, interesting, URI, oh, very interesting, look at that, that might be useful. And then we have user agent, look at that. So the user agent is bits admin, and that's actually a legitimate binary that can be used to download files, right? So the actual answer in this case is bits admin. And then it says the infected machine connected with a famous file sharing site. And in this case, it was also acting as the C2 server. What's the name of the file sharing site? And you already saw it. So this is literally what it was on the host that we got. So paste bin is the answer. And it says, what's the full URL of the C2 to which the infected host was connected? And so that was already here for us. So if we click on that URI again, this is it. So this is the full thing. So we add this to the end of paste bin, and that's our full URL. And we actually had that right here as well. So the last question is, what is the file? Or the last two questions is, what is the file and what's inside the file? So we copy that URL, and this one is kind of super basic, right? You copy the URL, you go to the URL, and look at that, we're already here. And so the name of the file is right damn in the middle of the screen, and it says secrets.txt. And then that, look at that, the code, the secret code that they were talking about is right on the screen too. So just like that, we now have the secret.txt, and then we have the secret code that has the format THM, yada, yada, yada. And just like that, we were able to use Kibana, which is a part of Elastic Suite. No, not Elastic Suite. I forget the name of what Elk does. ElasticStack. There you go, ElasticStack. And that's it, just like that. Very sweet, straight to the point. And we were able to collect all of our information and answer all of these questions. So just like that. Pretty cool, right? Oh, here I am. I'm right here. Hephaestus. That's me. That's my username here. I guess I was the last one. I don't know. I don't know what this number is right here. I don't get what that is. I don't understand what these points are. Why I didn't get any points. Whatever. Moving on. This was a pretty short and sweet video, so if you got any information from it, if you were able to learn a little bit extra, or if you were struggling to find some of the answers to these questions, if you got any value from it, or if you've ever gotten any value from my channel, I humbly request that you could like, subscribe, turn on notification bell, drop a comment, all that good stuff. All of those activities allow the YouTube algorithm to find us and to give us a little bit more reach so that we can grow the community. And then the more important piece of that is that if you actually subscribe and turn on notification bell, you'll get notified the next time a video comes out, which means if you're studying for the CYSA Plus, Cybersecurity Analyst, Pen Test Plus, Ethical Hacker, any of these things, all of these videos are actually going to apply to your studies and your career path. So you'll be getting real value, and hopefully I'll actually be able to kind of help you out in some way in your path. So that would be my request, and it would end up being a win-win situation in my opinion. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker, and we just finished the ItsyBitsy challenge using Kibana with ElasticStack. If no one else loves you, Hank loves you. And peace, love, and chicken grease. I will see you in the next video. Later. Alright, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And in today's video, we're going to be going over Splunk basics. This is a part of the SOC Level 1 pathway, and in the Security Information and Event Management module, so SIEM module. And we're going through Splunk, which is actually a very, very big name in cybersecurity analysis and SIEM software. So before we dive into the video, as always, I would sincerely appreciate it, and it would mean the world to me that if you like any of this content, if you get any value from this channel or from this video, it would mean the world to me if you could like, subscribe, and turn on the notification bell, and maybe even drop a comment, because all of those activities help YouTube algorithm find us and give the channel a little bit more reach so that we can grow the community and help as many people as we possibly can. And there's a, the secondary benefit, or maybe even the more important benefit, which is if you turn on the notification and subscribe, you actually get notified the next time a video comes out. And so if you're studying to become a cybersecurity analyst or a penetration tester or ethical hacker, so on and so forth, all of these things actually apply to your studies and to the day-to-day stuff that you're going to be doing as you go about your career. So yeah, it would be a win-win situation. Without further ado, let's jump into the introduction of the room. All right, so Splunk is one of the leading SIEMs in the market. Just like any other SIEM, it allows you to collect logs and parse them and consolidate them, analyze them, correlate, and put the dots together. Basically, connect the dots as to what's happening, and you can capture logs in real time by connecting to different endpoints. You can upload logs into it. Connect to various ports on your network, so on and so on. So it's pretty robust, and it's a very, very useful tool. And we're going to go over the overview of it, the basic components and how they work, how to ingest logs, and how to normalize logs so that you can kind of go through them. But it's a very, very robust tool. So this is literally just an introduction just to kind of get you familiar with the tool and the interface of it and how to upload logs and kind of search through the logs to try to find some basic information, and then we'll get into the deeper stuff as we go to the incident handling with Splunk and investigating with Splunk. So the first thing that we got to do is we got to connect with the lab, and if you've already seen any of these things, you understand what happens. So we click the start machine. Since it's loading a Splunk server, it takes about 3 to 5 minutes to start, and then in the meantime, you also want to start your attack box, which is the blue button that comes up here. I've already started both of them. As you see, they're already running, and the attack box has loaded inside of the new tab so that we can kind of look at it like this, make it a little bit easier. And from there, we can actually jump into the different components of Splunk, which is the Splunk forwarder, the Splunk indexer, and then search head to actually search through a lot of these things. And that's kind of the general components of Splunk, but again, there's just a lot more stuff that's available as well. The first question at the bottom asks us, what is the component that's used to collect and send data over Splunk? And that is the forwarder. It forwards information. In other SIEMs, they call this the agent. And so you have the forwarders or the agents. In this case, this is kind of what it looks like. It could be a Linux system, a Windows system, it could be a web portal, it could be a server, it could be a Mac OS. So any of these things could be your endpoints, which forward data to Splunk so that it can ingest and index it for you. And then we will be operating within the indexer today and using some basic search parameters just to kind of see what's going on and if we can find anything. And yeah, that's kind of the gist of it. So the rest of these exercises we're actually going to be doing inside of the Splunk server, this is what it looks like when you just load it and then you start it up. When you first load up Splunk, this is basically what it looks like, as you just saw. And then we have three main areas that we're looking at. We have this top black bar up here, we have this left sidebar, and then this center section that says Explore Splunk. And the top bar, very self-explanatory. You have messages, settings, activity, help, and then find. And then within that, you can click on apps for search and reporting. If you actually click on any of an app, it changes the top section of the bar. So for example, if we went right here and clicked on search and reporting, which is on the left side, this is what changes at the top black bar, right? And then you have the Explore Splunk section where you can add data, look at various applications that can operate within Splunk, and then of course the documentation of Splunk. And this is just a very general introduction to the dashboard, and you can kind of choose from pre-made dashboards or obviously create your own dashboard, and you can just do that by clicking choose, and then it gives you a bunch of different dashboard options that have been created, and then you can even customize your own and select from all the different data points that are available. And so if we click the add data tab, which option is used to collect from ports, and so we click on it, and then the options show up on the screen, and right here you see that these are the three different options that we have available. and upload from my computer. So files uploaded from the computer. You have files and ports on the platform, and you can use HTTP, WMI, TCP, yada, yada, yada. So this is actually the answer that we're looking for. And then forward comes from an endpoint that's forwarding data to us. And so the answer to collect data from files and ports would be monitor. And now we're gonna actually add some data and play around with this a little bit. So this is the gist, right? This is where you can source your data, files and directories, network events, IT ops, cloud services, database services, security services, virtualization services, application servers, Windows sources, and other sources. So there's a lot of stuff that you can use as your source that you can feed data into Splunk. What we are going to do is we're going to do add data, and we're going to drop a file from the desktop of our attack box into it, and then from there we're going to kind of create this little series of logs that we're going to be searching through. And then so it says, you know, you get a total of 5 steps to upload the data. You have the source, where we select the actual log, the source type, and it will be what type of logs that we're going to be ingesting, and you'll see what that means. The input settings, the index where the logs are going to be dumped, and host name to be associated with them, and then review, and then done. And you'll be able to actually search through everything and run it. So the host field value we can change. It comes pre-filled with a few different things, as you'll see. And then from here we'll be able to answer some of the questions that they have for us. So let's jump into it. We already clicked on add data, so we're going to click on upload, and from here we're going to click on select file. You can also drag and drop it. The file that I'm looking for is inside of my root, rooms, and Splunk basic directory, and this is the log. So it's a VPN log that comes in a JSON format. And real quick, you see how it finishes. So we're going to go here, click next, and then from here it actually kind of does the source type for us, right? So the source type here is JSON, right? And so you can actually do that, and then it could be saved as VPN logs JSON. So I'll just do VPN logs as the name, and then it's already JavaScript object notation, structured, all that stuff is all good. So we can save that, and then we can go next. And then from here we can also change the host field name, so it'll be VPN logs. It's going to be our thing. And from here we should, the rest of it is kind of just click through and make sure you got everything going, right? And so there's that. You get a confirmation, and now we can start searching. And so we're going to search through the logs that are loaded for us. And one thing that you'll notice is that it immediately has a query filled in for you. So the source is vpnlogs.json, host is VPN logs, and the source type is VPN logs. And then everything that we want to do after this is literally going to come after these commands. So we just leave this because this is where you can refer to a bunch of different logs if you've uploaded a bunch of different logs inside of Splunk, right? So we're going to leave this part, and then we're going to put all of our queries after the fact. So the first question is going to be how many events are presented in the file, and then we already have that 2,862 events, and that is our answer. The next question is how many log events are done by user Melina. And so if we just go down here, we can find something called username. So hopefully the screen kind of adjusts. There we go. So we click on username, and then it pops up all this stuff for us. And then from here we can look. So we have Melina has 60 counts for the events that have attached to her name. So we can go back, and so Melina has 60 counts. What is the name associated with IP? 107.14.182.38. And as I mentioned before, we literally are just going to go over here, and then you could do quotes and just paste it in there, end quotes. It's like a really easy way to search for it. And then it updates the number of events that we have, which in this case would be 26 events. And so we go back here, and now we have, what's the name associated with the guy? My bad. So the name associated with this, we can actually see it right here. So under each item, there's all this information that comes, source country, source IP, so on and so forth. And then username associated with is Smith. So there we go. That's the answer for that. What is the number of events that originated from all countries except France? So this is a nice little, kind of an advanced search, but not really. So the field that we're looking for is source country, right? So source country is what we're going to search for, and it's going to be, as long as it'll type for me, what we're going to do is we're going to do source country, and then exclamation equals means it does not equal. So source country does not equal France, and then this is kind of what it looks like. You do that. So source country does not equal France, meaning show me everything that is not with France, and then you press enter, and now we have the number right here, which is 2,814 events, which is the answer down here. And lastly is how many VPNs are observed by this particular IP, and so we copy that IP and we go back and we just repeat the same process. I just do that, and then I can paste it in here and press enter, and it gives me 14 events. Apart from that, there's a bunch of different fields that are available to us. So these are the selected fields that we are currently looking at, but then there's a bunch of other fields that you could look at. So the date can be broken down by a lot of different things. You also have the username that you can do, source IP, source country, source state even, the Splunk server that would be attached to, and then at the top of the screen we have, of course, the time. So you can do all time, you can do a range of times that you want to search through. It shows you the graph of how congested the data was on specific dates, and if you wanted to, you could just click on one of those and it will take you into that, and a bunch of different things, right? So we can search by pattern, we can search by statistics, and a lot of these things we're going to be looking at a little bit later. And then we can, of course, visualize everything and search by visualization, which in this case, it doesn't really have much. So this is basically a very surface level, short and sweet introduction to Splunk. It requires that you set up a Splunk server so that you can actually collect and ingest information. And then from there, you can either drop logs into it, or you could connect endpoints to it that will forward the data to Splunk. And then from here, we just literally click on Splunk Enterprise, and it takes us all the way back to the home page, and it'll show us kind of what we're looking at right here. And you can, if you click on Add Data one more time, it will show you a history of the stuff that you could have done before. So if I go to Upload here, and then get to the point that it does, there's a section, or you know what, maybe it wasn't here, but there was a section that shows you the history of the data that you had previously accessed and used, and then you can go through the various forms of the data. Maybe it's under search and reporting, and then let's see if we can find wherever it is, and there we go. So search history right here. So search and reporting, search history, and it'll open up a bunch of different things that we did. So it shows me all of the recent searches that I did. And if I wanted to just start back from the top, I could just go to the very, very first one that I did. And then this was the last exercise that I did before I recorded the video. So you can see how some of the information is different. It's the same VPN log, but I didn't change the host name. I just left it as the basic host name that came with it. And the source type was VPN logs because that was the name that I chose at the time. And then I was just doing these different search parameters just to see how it looks. And so there's a lot of other things that have already been done with this, so we could have always clicked on that to search through it, but I don't want to get too far ahead of ourselves. I don't want to kind of jump ahead and ruin the surprise, so to speak. So that's pretty much it for this room. I know this one was a little bit short and sweet, so we are definitely going to do more of a deep dive into Splunk as we go further down the SIEM pathway. So if you liked anything about this video, if you learned anything about this, even the introductory stuff about Splunk, or if you want to just stay tuned and get the rest of the videos that come out from this pathway, I encourage you to like, subscribe, turn on notification bell, and maybe even drop a comment. And all of those activities help the YouTube algorithm find the channel so that we can grow the community. But more importantly, if you like and turn on the notification bell, or if you subscribe and turn on notification bell, it actually notifies you the next time a video comes out from Splunk, and then you'll get more information and you can get more advanced with this, and so on and so forth. So I do encourage you to subscribe and turn on notification bell. I drop a video at least once a day, sometimes multiple times a day, and we'll try to maintain more of a consistent schedule with that, but at least once a day you can expect that a video will come out. And currently we're just going down the SOC Level 1 pathway, but I've done a lot of videos on Pentest Plus, and we're going to keep getting more and more advanced on the information that we have. So this is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And if no one else loves you, Hank loves you. Peace, love, and chicken grease. And I will see you in the next room. Later. All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And we are now inside the incident handling with Splunk room, which is a part of the SIEM module, the security information and event management module, inside the SOC Level 1 pathway of TryHackMe. And we're going to be doing some incident handling today with Splunk, and it should be a pretty extensive room, unlike the introduction room as we ran through it. I think in like maybe 10 minutes or something. It was like a very quick room. So this one is going to be a little bit more intensive, and I haven't done all the tasks in advance, so we're both going to be learning some cool things together. Before we jump into the introduction, I would like to humbly request and invite you to like, subscribe, turn on notification bell, and comment. All of those things actually leave a good taste in YouTube's mouth, so to speak. And they help the YouTube algorithm find our channel, give us a little bit more reach so that we can grow the community and help other people like yourself who are down their path with cybersecurity and ethical hacking, pen test, all that good stuff. And more importantly, if you turn on notification bell and subscribe, you'll actually get notified the next time a video comes out. And if you're starting to become an ethical hacker or a cybersecurity analyst, all of these things actually apply to you directly, and it'll help you with your studies as well as your general job function and your career pathway. So it would be like a nice, good win-win situation in my humble opinion, but that's just my opinion. And without further ado, let us jump into the introduction of the room, which is going to be incident handling. And so we're going to go through an incident handling scenario using Splunk, and it's basically an incident. I mean, I'm not going to read this whole stuff. You're more than welcome to just pause the screen if you want to read that. But it's basically anything that crashes the system, unwanted program ends up running, access to information that shouldn't be accessed by a user that shouldn't have that permission, a website being defaced by the attacker, meaning they messed up the website, they changed something on the website, they put a bad message on it, something like that. Or using USB devices when there's a restriction against USB devices in the company. The whole idea is to learn how to leverage OSINT, which is open source intelligence sites, during an investigation, how to map the attacker's activities to the cyber kill chain phases. And we've done a video on the cyber kill chain, so if you haven't seen that, go look it up inside the channel search bar, and you'll find the videos on the cyber kill chain, the unified kill chain, the diamond model, all that stuff. Then we gotta utilize Splunk searches to investigate logs and understand the importance of host-centric and network-centric log sources. And if you remember, as we started the SIEM module, host-centric has to do with an individual device or maybe even a series of devices. And then network-centric has to do with the entire network and the activity that goes on inside the network with all of the endpoints and all of the forwarders is what Splunk calls them, but all of the agents that are forwarding information into the server for ingestion and processing. Some of the prerequisites are obviously Splunk 101, which is the video that we did right before this video. So if you haven't seen it, feel free to go check that out real quick. And then we're going to just kind of learn how to, overview Splunk queries, so on and so forth. This is just like some of the basic stuff that I think we're going to be learning, or we should at least know how to do before we jump into this. And as we go through the rest of this room, obviously I'm going to be doing research in areas where I get stuck, and I'm going to cut that out in the edit, but you'll see the final result, and you'll see what I used, and then kind of the thought process of how I got to where I got, and we'll just kind of reverse engineer everything as we go along. So let's get into it. The incident handling lifecycle looks like this. It's like a continuous cycle. You prepare, you detect and analyze, you contain whatever situation needs to be contained, you eradicate whatever needs to be eradicated, you recover any data that needs to be recovered or any system that needs to be recovered, and then you have your post-incident reports and activities if you need to block certain IPs or if you need to train certain people, and then you start all over again. You prepare again, you detect and analyze, and then if there's anything that needs to be contained, eradicated, or recovered, so on and so forth. This is basically a never-ending cycle when it comes down to incident handling, cybersecurity, all that stuff. So preparation is, I mean, as the name implies, you need to prepare against an attack. So it could be documenting the requirements, defining policies, the security controls to monitor, so endpoint detection and response, SIEMs, intrusion defense, intrusion protection, all of these things. Intrusion detection, my bad. So intrusion detection, intrusion protection, etc., etc. And then, of course, there's the hiring and the training of the staff, which is kind of the most important part of this because the human element is the weakest link in the chain when it comes down to cybersecurity. Human error is one of the biggest deals when it comes down to cybersecurity. So just training people and letting them know what they should, they shouldn't do, so on and so forth. Very, very important. And then you have detection and analysis. And it covers everything related to detecting and analyzing the process, right? So it covers getting alerts from the SIEM and the endpoint detection and response systems, even the intrusion detection systems, and trying to find what just happened and what the root cause is, threat hunting, everything that goes on within that phase. And then once you've found something, then you need to prevent it from either spreading or destroying whatever's going on, and of course secure the network. And so this is kind of what containment really means, right? So if there's a virus or a plague or something, the first thing that they do is what's the word that I'm looking for? They contain the thing, but there's a specific word that I'm looking for. It'll come to quarantine. There you go. They quarantine, and they put somebody in a locked environment so that they can't spread the disease anymore. And that's exactly what containment in this situation really means. You isolate the infected host. Look at that. Literally, you isolate the infected host. You quarantine that host. You disconnect it from the internet and remove it from the network. And then you clear the network from any infected traces, which means eradicating all of the traces of the virus, and then recover whatever you need to recover, whether it's the system, whether information that was lost, so on and so forth. And then there's the post-incident and lessons learned. This is so funny that they did learned. It's learned, lessons learned. This phase includes identifying the loopholes, which led to the intrusion and improving so that it doesn't happen again, and then involving identifying weaknesses that led to the attack, adding detection rules, training people again, and look, most importantly, training the staff if required, which it is required. It's like all the time. It's something that should be happening all the time. Big organizations have regular trainings when it comes down to cybersecurity, information security, and all that stuff. So this isn't something that's a one-time thing, and people are typically flawed entities, and so they forget sometimes, or some guy shows up to the training high or whatever. Like they just don't, they have short-term memory issues, you know what I'm saying? So that's kind of the overall philosophy here, is that you need to, this is like a repetitive cycle, and it's continuous, and it happens all the time, forever and ever. So that's the incident handling life cycle. And now we're going to jump into the incident handling scenario. All right, in this scenario, what's happened is that the attacker defaced the organization's website, and we have Splunk that's set up, which is awesome. And we want to investigate the attack and map the activities to all of the cyber kill chain phases, which is these are the phases. We got recon, weaponization, delivery, exploitation, installation, command and control, and then the action that they took on their objectives, which is defacing our websites, probably. And so in this situation, we're going to be connecting everything to each one of these steps, right? So this is the website. What happened? They defaced the website, which is imreallynotbatman.com, and your site has been defaced, basically. Poison Ivy was here. Deal with it, admin. That's kind of it. That's what's going on. So they've requested us to join them as a security analyst, and we're going to be going to the detection and analysis phase, and we're going to be using Splunk as our main thing, and the logs are being ingested from the web server, firewall, Suricata, Sysmon, etc. So there's going to be a lot of logs, it seems like, and we're going to have to try to figure out what the hell is going on. So some of the interesting log sources that will help us are the Win event log. It contains Windows events. Win registry contains the logs related to registry creation, modification, deletion. The XML Win event log, which is the Sysmon event logs, and FortiGate UTM. So it's the Fortinet firewall logs. Never heard of that. IIS web server, Nessus scans, the Suricata IDS intrusion detection system, the HTTP stream, the DNS stream, and the ICMP streams. And all event logs are going to investigate, and they're going to be inside the index BOTSV1 and the Splunk and a lot of other SIEM software. So for example, Kibana, which is something that we did a couple of videos on, they also work with indexes or indices, where that's kind of where all of the data is being hosted inside this one index. So this is going to be what we're working with. That's the index that we're working with. And we need to launch the machine, which I thought I did, but for some reason it's not loading. It says showing in 0 seconds, but it hasn't loaded. So we'll refresh the screen and see what's going on over here. Okay, so we do have our not victim machine, our IP address that's associated with the Splunk server. That's already loaded, but I do need to give the attack box some time to load because that's how we're going to access that server. So while that's running, we're going to look at the reconnaissance phase of this investigation. So it's an attempt to discover and collect information about our target. That's what recon means. They use that a lot in military operations, so you should be pretty familiar with that. What we're going to do is we're going to examine any attempt against the web server imreallynotbatman.com. From our perspective, what we need to do, look at the available log sources. We'll find some log sources covering the network, which means that all the inbound communication towards our web server will be logged into the log source that contains the web traffic. So by that, it would be index. This is the index that we're searching through. And then imreallynotbatman.com. That's basically what we're going to be doing. And then the explanation to this is we're going to look for the event logs in the index. That is bots v1. And then which contains the term I'm really not Batman. So out of everything that's inside that, and if you look at this, there's like, what is it? I think like 60,000 events, or no, I'm sorry, 78,000 events in total. And so out of the 78,000 events, we want to try to kind of zoom in and hone in on this particular series of events. And not even that, you know what? Look at this. All in all, there is 957,000 events that apparently exist inside this particular Splunk server. And then from there, we're going into the bots v1, which has 70 something thousand. And then from there, we're going to take out of that 78,000, we're going to hone in on the I'm really not Batman. And so when we search for that, we see that the following sources contain the traces: Suricata, Stream, HTTP, FortiGate, and IIS. From these sources, it's clear that each source may contain something, so you can kind of tell what they all want. So Suricata is the IDS, this is the HTTP stream, you have the FortiGate, and then the IIS, right? So every analyst could have a different approach to this, and our first task is to identify the IP address attempting to perform this. So what is the source IP address that's trying to attack us? And this is the specific query that we're going to be looking for. So source IP field from the left panel will show us what all of that is. And so the query to be able to look for it would be this part, which we already saw. And now we want source type stream HTTP. And then so what we're going to see is that it's going to look for the I'm not really Batman, I'm really not Batman, whatever, inside the HTTP stream. And then we'll see that in this case, it seems like that there's only 2 source IP addresses inside the HTTP stream. And now we have this breakdown. So we found 2 IPs in this, and these are the 2 IPs. So now we can try to further research these IPs. So this particular IP, we're going to click on it, examine the logs that have to do with it, and look at interesting fields like the user agent, which we saw in the intro to Splunk, the post requests, the URIs, and so on and so forth. And then validate the IP that's scanning. So we're going to look into the Suricata logs. And so same index, same domain, source IP has now changed, and the source type is now Suricata. So we can see further information about this whole thing. And then now we're going to be able to answer some of these questions. So one Suricata alert highlighted the CVE associated with the attacked attempt. What's the CVE value? We're going to find that. What is the CMS our web server is using? What is the web server that the attacker used to perform the scanning attempts? And what is the IP address of the server? I'm really not Batman. So we're going to kind of hone in on these things, and our attack box should be up and running by now. So let's open this thing up in a new tab so that we can look at it in the full screen and get some really, really good information going. And so what I'm going to do in this particular case, as I usually do, is I'm going to shrink this down, and I'm going to open this up inside my second monitor so that we can just hone in on the actual attack box and then kind of work our way up from here. So first we open up the Firefox browser and we go to the IP address where our Splunk is being hosted, which is 10.10.235.246. And just like that, it should load. And so the first thing that we're going to do, and I'm just going to run literally all the stuff that we just read through, I'm going to run those commands. And for the next task, since they seem to be giving us all of the commands that we should be searching for that task, I'm just going to kind of skim through everything that we got to do, and then we'll actually run the commands so that we can find the information in real time instead of just looking at logs, or not logs, excuse me, screenshots, instead of looking at screenshots. So we're here, we're in the search and report section, and the first thing that we want to do is we want to look at our index, right? So the index that they gave us was index equals bots version 1, and there it is. And then now I'm really not Batman.com, not Badman, Batman.com. There we go. And press enter, and it's impossible that it says, oh, you know what, I'm going to turn this from last 24 hours. I'm going to go to all time, and then we should be able to see some information. There we go. So we got these things. Good stuff, good stuff. And so I'm really not Batman. We need the IP address of I'm really not Batman first and foremost, which is going to be the destination port, or not the destination port, the destination IP, I would say in this case. So one of the things that I could do, if I click on host, it'll show Suricata, Splunk, all that stuff. We have the source, which shows us all of these fields. Source type is also Suricata. So in that case, it might be destination that we're looking for. And so if we go to DEST by itself would be the destination, which is I'm really not Batman. And then DEST IP, which would be probably one of these guys right here. So let's see if we could just do DEST, click on I'm really not Batman, and see what we can find here. And so right here it says destination IP is 4080.148.42. And so if that's the destination that we're pointing towards, I wonder if that's actually our IP address, the destination IP address, or the IP address for Batman. Although I don't think it is, because in the documentation it said that that's what we identified as potential malicious IP addresses. So if that's the case, then we could just kind of assume that the other one is it. But I'm just going to do the nslookup.io. It's a useful little tool. And then we're going to do I'm really not Batman.com, see if anything shows up here. And so we got a couple right here. 172.67, 104.21. So if I go here, do I see any of that here? I don't see any of those here. So it might not be the actual case. I think this might be it. I think the 192.168 might actually be the address of I'm really not Batman. So let's see if that's actually the case. Yep, that's the case. Okay, cool. So one Suricata alert highlighted the CVE valued associated with the attack. So what does the hint say? It says look at the log source type Suricata. Okay, fine. So we're gonna look at so we're gonna get rid of this part of our query, and from here we'll just press enter, and then we're going to click on source type, and then click on Suricata. And so now the source type is going to look like this, and we are looking for a CVE value. So let's see what we can find for a potential CVE value. Okay, so nifty and neat little thing that comes here is the autofill option, which is freaking amazing. And so when we just do, open quotes CVE, it gives us a couple of CVE identifiers that show up inside our log file. And so if I click on the first one and press enter, what it does is shows you the kind of like the JSON version of this thing. But then what you want to do is you just want to do click on raw text, and now it shows you the raw version of this, and it gives us possible Oracle reports, and then you actually see the CVE identifier inside it, and it's a web application attack, so on and so forth. So this could very well be it. I'm not sure if this is actually it. I'm going to copy it, and I'm going to see if this is the thing. So if I do Control C, maybe that'll be the option. And so if I do this, that is not the one. So we can kind of move on from this one. We'll do the next one, which is 2014, and see how many results show up with this. And 36 events show up with this one, with the destination IP, which is our domain, and the source IP, which is the bad IP. And so maybe it's this one. Let's see if it's this one. At this point, I kind of feel like I have to try all of them, but let's see. We'll do this. Yeah, that's the one. Okay, and so let's look at this one a little bit further to see what actually is associated with this CVE. So it says the signature is web server possible attempt. That's kind of all it says. Is really, it says ET web server possible attempt. So there is that. And so if I look at it, if I look at the next item as a raw text, and it says same thing, ET web server possible attempt in headers, so on and so forth. So that's what we got for our CVE value. And now it says the CMS our web server is using. So what is the CMS that our web server is using? So the I am not Batman, if you go into the information here, we should be able to see a little bit more about our specific CMS that we might be using. All right, so for this one, we had to change our source type from Suricata to HTTP stream:/HTTP. And then when you do that, you can actually see the headers, the source headers of everything. And if you just kind of zoom in a little bit on the domain name, right after the domain name, there's something called Joomla. And I used to mess with this when I was doing web development a little bit. And it is a CMS, like a customer management system. I think that's what it actually stands for. And so just try that as an answer, and that actually is the answer, which is Joomla. And so now it says, what is the web scanner that the attacker used to perform his scanning attempts? The information for this could probably either be inside the FortiGate thing. So source type FortiGate, and we could do FortiGate, or maybe Suricata, because FortiGate is, what is it? It's the firewall log. So maybe it's Suricata actually. And for this, we want to see what kind of scan was really done. So we do Suricata, and then it loads again. And what we want to see is from the source IP. So I think that's another thing that I could change to see from the source IP that was 4080 yada yada yada. Let's see what we can find over there. So it's source equals 4080 148 42, and from here let's see if we can find anything of interest. Okay, so this is under the HTTP user agent, and I think the search query is still, yeah, Suricata, and then just the source IP is the IP of the attacker. And so when we go under HTTP user agent, there are several user agents, and then you see something that's kind of interesting, which is print MD5 Acunetics WVS security test. And this has shown up a few times. MD5 is an algorithm for hashes, and then there is the WVS web something scanner. I'm going to say web vulnerability scanner, probably that's what that stands for. And then you have the name itself, which is Acunetics. So I'm going to try Acunetics. Yeah, okay, there it is. So Acunetics is the answer for this particular case. And so there we go. We just wrapped the reconnaissance phase of the Splunk incident handling. So now we're going to go into exploitation phase. All right, for exploitation, here's what we got to read up on. To begin the investigation, let's note the information we have so far. We found 2 IP addresses with sending requests to our server. The IP was this, and it was attempting to scan the server with IP this, which is our domain names IP address. The attacker was using the web scanner Acunetics for these scanning attempts. And so now what we want to do is we want to find the count of certain things, it seems. So what I'm going to do, I'm just going to actually run these commands instead of kind of just reading about them. So what we want to run is this particular command, which is index. I think I might be able to even copy and paste this. So we're going to just copy this real quick, and we're going to go here, and we'll go to the very top, and we're just going to paste it. Yeah, very good. So what we're looking for here is we're going through the stream of anything, so any type of stream. We're trying to count the source IP as requests by source IP and sort through them. So let's see what we can find if we did that. And there were 78,000, and we got the count is right here, so 17,483 and 1235. And so that was from this thing, Jesus, 17,483 was from that. Is that an answer that we're looking for by any chance? Let's see if it is. Look at all this. We have to read through all that. So against which username was the brute force made? What was the correct password? How many unique passwords? Okay, none of this stuff. So, okay, so that was the first part, is trying to find the count of the attempts. And so I guess we need to kind of read through all this, and after this we'll be left with the place to find out where we need to go. So when we do the count, it shows it, and we just did it right now. And so we can also create different visualizations to show the results. So we could just do visualization, pie chart, etc., and that's what that looks like. We'll narrow down the results to show requests sent to the web server, which is this thing. So the query will end up being the stream HTTP destination IP is going to be that. And then from there, we're going to see these values. So that IP address, the source IP, has the 17,000 count. And then we have two other IPs that showed it to us, and 91% of all the traffic is literally coming from this place, from that one IP. And then when you look at the HTTP methods, we see that there's a post, get, there's the options, connect, prop, find, and trace, and obviously the substantially largest one is the post request, meaning they're trying to send stuff to the web server. And from here, we can hone in on this, right? So we have HTTP stream, destination IP is us, and now we want to look at the post methods. And then you look at the source IP, now there's this IP, and then there's the other remote server. And then the interesting fields would be in the left panel. We have source IP, form data, the user agent, and the URI. So the source IP, the form data, which is the information sent via form, the user agent that was used, and the URI, which is the link basically. And so we see that prompt, and then there's the Acunetics again that they saw, and then so we click on server, and we get to see the server, we get to see the source that it's coming from, the URI path. Look at that, that seems sketch by itself. The URI in itself and the URI path, this is very, very sketch. Okay, some interesting information. This is the source content, that this document may be found at such and such. So basically what they did was they clicked on the source IP, and then once it loaded, he clicked on, the cookies, just to see the cookie information that came from that. He clicked on the destination IP, which is our server, the form data that was submitted. So we'll see the stuff that has been gone through the form, the Acunetics scan, and then we have the request that was sent, and post request, mostly the server that was attached, the Splunk server that we're using, the source, and then the URI and the URI path, so on and so forth. A little research for the admin page of Joomla will show that Joomla Administrator Index is a form. So it contains the login page for the Joomla portal. And so referencing the Administrator Index link, we can narrow this down. So on this website, source type, destination, and then now the URI is the Joomla Administrator. And then from here, now we see that there's form data plus 100, and you get to kind of look at it and to see what potentially was sent. So get their contents and send what both change directory, event, direct option, and then Joomla, Explorer, so on and so forth. So the form data contains the request sent through the form on the admin panel, which has a login page. We suspect the attacker might have tried to use multiple credentials and attempt to gain access. And so now we kind of hone in on that. So the method is a post method, the URI is that, and then the table time and the URI and the source port and destination port and form data are the fields that we're interested in. So the time, the URI, the source, destination, and the form data is what we'll end up seeing in statistics. And I think that's what happens is when you do the pipe as a split, and then from there you use the table parameter or the table option, and then you kind of put all of the different things that you want to see in that. And then you start seeing the passwords and all the different passwords that was attempted. Hilarious password. Ha! That's funny. And so we have the various attempts at the password. And so if we keep looking at the results, we'll find two interesting field names. We have the username with a single username, admin, and then a password that contains multiple passwords, which shows the attacker from this was trying to guess the password by brute forcing. The time elapsed between the events also suggests that the attacker was using an automated tool as various attempts were in a short period of time. So extracting the username and password fields using regular expressions. So we would modify our form data field with this. So form data, username, and password in the above search. So all of the stuff is the same, and we just added right after the URI, we added the form data, and then we pulled the same stuff from the table. So the time, URI, so on and so forth. And now we only got the username that was taken and pulled out, and then there should probably be a series for just the passwords as well. And then so it's time to use regex to extract all the password values. To do so, Splunk has a function called rex, and if we type it in the search, it'll show the detailed an example of how to use it using the exact value. So you do rex, and then it shows you what you can potentially pull out of it. So we're going to use regular expressions. So rex field form data and password, that would be the regular expression formula to extract passwords only. This will pick the form data and extract all the values found within the credential. So again, the index, the source type, destination IP, HTTP method is going to be post, form data is username and password, everything with these wildcard characters. And then now we're using rex before we do the table. So we do rex, the field, which is going to be from form data, and we want password, everything that might be in there. And then the table is only going to show you the source IP and the credentials that comes from it. And then you press enter on that, and it will take a second. So there you go. And you got the source IP, and then the URI, and then all the different passwords that were used. So now we are going to examine the fields and find two values against the user agent that is available below. And one of them is Mozilla, Trident, and the other one is Python URL library, which is the bulk of the stuff. And it seems like they were using the Python. So the first value clearly shows that they used the Python script to automate the attack, but one request came from a Mozilla. Why? That's probably the one that actually had the successful username and password, right? So to find this, let's slightly change and add HTTP in the search field, and we're going to append table, time, source, URI, HTTP agent, and credentials. And then we'll end up seeing that the Mozilla one had the credential Batman attached to it, which most likely probably means that that was the password. So the search query is going to look like this, and we have everything exactly the same with the exception of adding the HTTP user agent in there. And we added the time back to it and URI and all that stuff. And so that kind of shows that a continuous brute force attack and one password attempt Batman from IP using the Mozilla browser. So what was the URI, which got multiple brute force attempts? And we can kind of just pull that from the information on this page. We don't even need to go very far with that. So it's going to be this. So this is the URI that got multiple attempts, which is the administrator login. So we're going to paste that in here, and that's going to be the answer. Against which username was the brute force attack, which was admin. What was the correct password for admin? For the thing, it's Batman. How many unique passwords were attempted in the brute force attempt? That is what I don't have. Let's see if we can find it from this response right here. So it says extracting username and passwords, and we got, so from here they used this where they pulled all the usernames and passwords, or maybe it was the one that was up here actually. So it could be 425, which it shows in the statistics line item right here that it has everything to do with the administrator index thing. So could be 425, it could be 424 since they had one successful login. Can I get out of this, please? Very good. And so let's try 425, but I think it's 424, honestly. Yeah, it's 424 maybe. Nope, that's not it either. Okay, so that is something that we do have to try to find. This is, oh, this could actually be the answer right here. So 413, because it could have been other things probably that was done. So 413, and I'm going to run that. That's not it. 412, that's the answer. So there were 4 for 13 altogether, including the correct password, and then 412 were all of the attempts to try to find the password. So a lot of the information has been extracted and done for us. What IP address is likely attempting a brute force attack against the I'm not Batman? And it's actually the 22 IP address. It's not the 44 IP address. That is the main differentiator, because they found out that this IP was the one that was doing all the brute force attempts, and then the 44 was the one that actually got the login. After finding the correct password, which IP did the attacker use to actually do the login, which is this one right here. So this one, all of the answers actually were on the task exercise for us. So we didn't have to run any of these commands, but it's good to know that this is kind of how you filter through it. And I mean, in the interest of time, I'm not going to rerun all of this stuff because they literally did all the work for us. And all we had to do was just kind of pay attention to what was going on and be able to extract that information. So now there is the exploitation phase that we just went through, and the next piece is going to be the installation phase. So what they did was actually install whatever the malware was or what they were planning on doing. So let's go and check that out. All right, so we have the installation phase. And in the installation phase is when things get installed. So we found evidence that this was getting compromised via brute force. We found that the destination IP was that, and we found the 2 IP addresses that were doing the attacking. So now we need to narrow down anything coming into the server containing an executable. .exe means an executable. So the query for that is the index, the source would be the stream HTTP, destination IP is that, and now you're just searching for anything that has an executable. So the wildcard character .exe will end up giving you the potential executables that come in, and from here you have a bunch of different information as always that you can kind of go through. And then so cmd.exe was one of them, which could be a command line executable. And so if we go to all fields and we're going to search for file, there you go. So file name field, and it'll give us the, oh, that's cool. It also shows you the value. So I guess there was an agent, or no, excuse me, not agent, 3791.exe could have been the information. So 3791, there it is, 3791.exe, and a PHP file called agent. And so this is the information that was extracted from it. And I guess I didn't need to look at the GIF because they literally do all of the analysis for us. So we had the bots1, stream HTTP, destination IP, and part of the file name equals 3791.exe. And so that pulls the full information for us. And there's one event that comes from the IP address that has been flagged as the malicious IP. And so it was uploaded on the server, and this file was executed on the server. Well, that's kind of the big question, I guess. We need to narrow it down. So we're going to go and search for this inside all of the index itself, and there's a bunch of things that show up. And so you have XML win event log, the win event log, the FortiGate, UTM, as well as the HTTP, and as well as Suricata that show a bunch of different things. And the XML win event log seems to have most of the activity. So following the host-centric log, we found that there's traces of this executable on these main logs. And so for execution, we can leverage sysmon and look at the event code 1 for program execution, and that's what this is. So event process 1, event provides extended information about a newly created process. So we do the search query to look for that executable. The source type is going to be this log now, and then we want the event code 1. And so for that, we got 5 events that showed up, and 4 of them were command line events. And so there is the person, what is it? I think the order is command.exe, and then they tried to run that, and then I don't know if this is in order. We would have to look at the timestamps for it, but that's basically what they did. So looking at the output, we can clearly see that this file was executed on the server. We can also look at other host-centric logs to confirm the results. So sysmon also collects the hash value of the processes being created. What is the MD5 hash of the program 3791? So what we can do is we can go and use as our source type the sysmon. So I'm just going to take this thing and copy it, and I'm going to go look for MD5 hash. So I'll do this, I'll paste this in here and drop that, and then it's going to run for us, and there's 69 events. And from here, I guess what I'm going to do is I'm going to look for MD5, and it's going to show me 67 events now. And so from here, let's see if we can find that hash value. Hashes, and these are all the hashes that are here. So a bunch of different things, and they have to do with the executable itself. So I can only imagine that these are the various hash types that come in here, and then we have these different hashes. So let me kind of pull that out and go look at the MD5 hash, which is right here. And so we have MD5 hash out of this thing, which could be this whole thing right here. So we're going to copy this and see if this is our answer. Yep, that is the MD5 hash value. Now looking at the logs, which user executed the program 3791 on the server? So looking at the logs, which user executed it on the server? And there was one that had only one event that showed up, which is this particular event right here. So I'm gonna use this thing and see if this ends up being the one that we got. Or no, you know what? We need to find the ones that are host related. So if they're host related, it would have to be this thing. It would have to be these series of log files. So it would be one of these things. And so we can even just go back to this, and from here we can look at, delete all of these hashes real quick and look at the events that come out, and then try to find something that we would potentially be able to find the username. All right, the answer is inside of this search. So it's basically the same thing that they searched for and they showed it to us. So we're going to use the XML win event log and event code 1. And then there's actually a field called user. So you just come down and there's one user associated with all of this activity, and it is this user right here, the NT authority. So we're gonna try that as an answer, and I'm willing to bet that that is indeed the answer. Yeah. So search hash on VirusTotal. What is the other name associated with this specific thing? So search the hash on VirusTotal. What is the other name associated with this? So we're gonna take this hash, copy, and we're just gonna open it up inside VirusTotal. And search via the hash, which is going to give us ab.exe, and I'm pretty sure that's the answer. So ab.exe, and there we go, we got it. So that was the installation. Can we zoom out? Yeah, that was the installation portion of our incident response for Splunk. Now moving on to action on objectives. All right, action on objectives. Since the website was defaced due to a successful attack, it would be helpful to understand what ended up on the website that caused the defacement. And as an analyst, we got to figure that out. So we're looking at the same index, same destination, and now we're looking at Suricata, the IDS. And we see that the source IP addresses were two various IP addresses, which this is interesting in this case, because they're not the same malicious IPs, right? And so we have these two other IPs, and the logs don't show anything external communicating with the server. So we're going to change the flow of the direction of this thing. So the destination, instead of this being the destination, we're going to look at the source destination being this, which is, it's actually the same exact IP address. So now instead of having it be the destination, we're looking at this being the source. And now we see that the destination IPs are our malicious IPs. So they don't originate the traffic. It implies that there's a reverse shell happening, I think. So let's see, the browser or the client would be the source and the server would be the destination. Here we see 3 external IPs towards which the server initiates outbound traffic, and there's a large chunk of traffic. So if we look at that, so source type or source destination would be that, source type Suricata destination would be these things. We can see that it's the Joomla administrator, the Joomla agent, and Poison Ivy is coming for you, Batman. Oh, the JPEG. So that's the JPEG that was probably replaced over there. So now the URI or the URL here includes Poison Ivy is looking for you, and destination is us, table, we want the time, the source destination IP, and the host name and the URL. And so when we look at that, we see that what was happening exactly. So he's going to pull the table up. So we'll see that from here. So suspicious JPEGs were downloaded from the attacker's host, and this is the host that defaced the site. So what is the name of the file that defaced the Batman site? It's this thing. It's literally a JPEG that was on the Batman site. And so FortiGate firewall detected SQL attempt from the attacker's IP. What is the name of the rule that was triggered during the SQL injection attempt? So we're going to end up using FortiGate, and we want the attack field. So we're going to go and do what? We're going to end up doing something like this, right? So from the attacker, so we'll do source, and then we'll do FortiGate, and we'll do destination is going to be us. So we're just going to change a couple of these things here. So we'll copy this here. I'm going to go over here. We're going to paste it over here, and the destination is actually going to be this thing, and then the source is going to be this. I think, was it 23 or was it the 44 address? I think it was the 44 address. Yeah, the 40 address. So this is actually going to be the source. So since that's the source, and we're going to use Suricata, I'm going to paste that in here, and let's do an entrance. There has to be something. Oh, it's loading. Okay, cool, we got this, and then now we're looking for the attack field. I forgot to change this to FortiGate UTM, and now let's look at this. And now we do have an attack field, so we're going to look at the attack field. And what are we looking at here? So we want to see the SQL query that kind of messed this whole thing up. So PHP argument injection is probably it. HTTP SQL injection, I think this is it. This is the one. So let's go here and do that, submit. And that is it. Okay, excellent. So moving right along from that to command and control phase, which is kind of going through, I mean, we're going out of order with this whole thing, because attack action on objectives is the last specific phase of the cyber kill chain. But we're just going to move right along to command and control. The attacker uploaded the file to the server before defacing it. While doing so, the attacker used the dynamic DNS to resolve a malicious IP. The objective is to find the IP that the attacker decided the DNS. And so we're going to use FortiGate UTM, and this is going to be our query, and we're doing Poison Ivy yada 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 JPEG as the search. And so there's going to be 3 events that are going to come back from this: the source IP, we can notice, and the URL. And there was a prank glass in bracket, whatever, that was the DNS, I think, the domain or the server, the web service that they used to do it. And so looking into the logs, we can see that the source IP, destination IP, and URL, and we look at the URL, and it contains the fully qualified domain name, the FQDN, the fully qualified domain name, which is like this full thing. And from here, we're going to further hone in. And so we have now looking at the stream HTTP, the destination is going to be the attacker, this is going to be the JPEG, and the source is going to be our web server. And so now we see that the destination, and then there was a GET request from the destination, meaning the source IP would have sent the GET request, and then the destination would have received it. I think that's how it works. So the request is get this, and the site is this thing. And then the source IP is this, and the URI is that. So we've identified the suspicious domain as a command and control server which the attacker contacted. We can also confirm by looking at the last log source to see what DNS queries were sent. This attack used dynamic DNS to resolve to the malicious IP what fully qualified domain name is associated with this attack, which is this full thing right here. So it would be the prankglassjumpingcrab.com. So prankglass ein bracket, okay, so prankglass ein bracket dot jumpingcrab.com. So prankglass ein bracket dot jumpingglass.com. Is that close? Jumpingglass.com, like that? No, that's not it. So that does not seem to be it. Prankglass ein bracket jumpingcrab.com. There we go. Okay, there you go. there's the full domain name. Now moving on to the weaponization phase. All right, in the weaponization phase, and again, this kind of feels a little bit out of order here, but the adversaries would create the malware, malicious document to gain the access, evade detection, establish domain similar to the target domain, create a command and control server, so on and so forth. So far we found that this is the domain that was associated with the C2, the command and control server. So now we're trying to find some extra information about this thing. And so what we do is use Robtex. I've actually never used this before. So it's a threat intelligence site that provides information about IP addresses, domain names, and so on and so forth. So robtex.com, DNS lookup, and then we did the pranking glass, whatever, prank glass, whatever, that domain. And then it gives us some quick information about it, including the IP addresses that are associated with it. So there's also siblings to this that have been previously used. So other domain names that have previously been used, and jumpingcrab.com seems to be the main domain, and then there's a bunch of subdomains that are associated with it. And so the reference would be this specific thing that we could probably go to right now. And now we're going to search for the IP address 22, 2322, etc. on this specific site as well. So instead of DNS, we're going to do IP lookup, and we're going to run that. And then now we see there is different websites associated with that IP address, like Wayne CRP Inc., Wayne Corp Inc., so on and so forth. So what we found is that this IP is associated with domains that look pretty similar to Wayne Enterprises, and that's what that looks like. And so these are all the different IPs. And now we can go to VirusTotal and run that same IP address. And then we can see a bunch of different DNS replication that has happened. Nothing was detected, so none of the malware or virus scanners found anything wrong with it, it seems, except the specific EXEs that are applicable to it, but none of the actual services found anything wrong with them. So in the domain list, we see that the domain associated with poisonivy.com, let us search for that domain. So we search for that, and now there's some detections on that. And then we also look for who is information on the who is domain tools. and we look for poison ivy, and we see that the name servers that are associated with this as well. So what IP has poison ivy tied to domains that are pre-staged to attack Wayne enterprises? So that is what we're trying to find, and it seems to be what is it, 6429 151 221 221. Yeah, 6429 151 221. 6429 151 221. Is that it? Nope, that's not it. So that is not the right answer. So it could be the other one. So why don't we just actually run it, huh? Let's actually go to this thing right here. We'll copy this, and we're gonna go to, oi, get out please. Zoom out, buddy, what's going on? There we go. Gonna go to VirusTotal, and we're gonna search for poison ivy, and it's clean. Look at that. There's like nothing associated with this. That's so crazy. Why is it clean? Shouldn't be clean. And we have these domains. These two have detections. This one that we just used didn't have any detections associated with it. And there's a variation of things. So I guess I'll just try the ones that have some kind of a detection, right? That kind of would be the only one that really makes sense, doesn't it? So if it's not the 64 one, it's not that one either. So it has to be this one. Otherwise, I am at a loss. No, that's not it either. So what IP address has poison ivy tied to domains that are pre-staged to attack Wayne enterprises? Okay, well, the answer was the IP address that we've been using this whole time to do our detection, and it's this thing right here. So it's this IP is the one that was attached to all of these Wayne Corp dummy domain names. So that's it. Okay, so now based on the data that's been gathered from this attack and the common open source intelligence sources for domain names, what is the email address that is most likely associated with poison ivy's advanced persistent threat group? And it seems to be this contact right here. So I guess we can go and actually look at it on whoisdomain.tools and look for poisonivy.com to be able to just copy and paste that email address real quick. So we're gonna go here, gonna paste that in here, click search, validation required. I am not a robot. Please continue. And so under the who is record, there is some contact information that should be down here. And there is, let's see, it was on the other thing, so now it's redacted for privacy, huh? Look at that. So she doesn't want to be caught anymore. So maybe it's over here somewhere. All right, so the hint sent us to OTX Alien Vault. And I just did a search in the search bar at the top for poison ivy. And right on the front, there are a few different pieces of information. And one of them happens to be the email address. So if we take this and go over here and give it a shot, might not be the address, it's not the address. So it's like something.something.com. So that might be our little hint here. All right, so searching for Wayne Corp Inc., spelled like that, we have lillian.rose at poisonivy.com. That could be a decent attempt. So let's see what we can find for that. That might be it. Is that it? That's it. So Lillian Rose at poisonivy.com. Fair enough. And last but not least, we are now going to go into the delivery phase of this whole thing. And let's see what we got here. The delivery phase includes people or attackers creating malware and infecting devices to gain initial access or evade defenses and find ways to deliver through different means. We've identified a lot of things, and now we want to use the information we have to perform, threat hunting, or use OSINT sites to find any malware linked with the adversary. Poison Ivy appears to have a secondary attack vector in the case that the initial compromise fails, and so we have VirusTotal that we used already. There's Threat Miner, there's Hybrid Analysis that we could use, and by doing Threat Miner search for the malicious IP right here, and I'm just going to copy this for now. This is what shows up. So there is several hashes, MD5 hashes that are associated with it. And then we have a bunch of information that comes from this. So there's the Agent 5 AVG, then you have their Trojans. There's a lot of things that comes out of just running that little hash. And from there, so the 3 hash files, one of them, which was this one, is malicious and something of interest. So if we click on it, we can see the metadata and other information about it. The date was done in 2016. This is the 256 hash, and we can search it on VirusTotal, VirusShare, so on and so forth. So that's the reference for that specific one. And then if we took that 256 hash right here and ran it on VirusTotal, we would see the Miranda Tate screensaver that is attached with this right here. And so you can click on the relations and look at that. Lo and behold, you have the IP address, and then there's even a contacted tips. I don't know if they meant to point to this for us, but there's a one contacted IPS right here. So then we go to the hybrid analysis website and look for that executable, which can, so hybrid analysis I haven't used before, and what it can do is get us network communication, DNS requests, contacted hosts, strings, MITRE attack mapping, malicious indicators, a bunch of stuff. So hybrid analysis, we run the executable Miranda Tate screensaver in here, and of course it's flagged as malicious, and then you can see the SHA-256 on here, which is also the same thing that we just found. So what is the hash of the malware associated with the APT group? That one was too short to be the SHA-256, because the SHA-256 is super long. So there should be the hash available here, and that's the hash. So we're just going to go and run that over here, and I think that's it. And that is the hash. And what is the name of the malware associated? And that is going to be the Miranda Tate malware. And there's no copy-paste version of it over here, so I just got to type it up real quick. And that is going to be Miranda Tate screensaver.scr.exe. So let's do that. And just like that, ladies and gentlemen, we have finished our exercise for Splunk. And this was super fun. I actually enjoyed it. Maybe I'm just a big nerd or something, but the incident handling exercise with Splunk has now been wrapped. And I am very, very excited to be able to say that I've done some decent incident handling exercises with Splunk. In conclusion, we went through a lot of things. So here's the overview, right? We did the reconnaissance phase, and we found the IP address that was found to be scanning our web server. And he was using Acunetics as the web scanner. Then there was the exploitation phase, where he did a brute force attack originating from this IP. And then this was the IP that he actually used, which was the same IP right here, to actually log in. And there was 142 brute force attempts made against the server, out of which one of them was successful. And this is not the right number. It's 412, not 142. Whoever typed this up just misspelled that. So it was 412 brute force attempts, and one of them was successful for a total of 413. Then there was the malicious executable in the installation phase. That was 3791, and it was uploaded, and we looked at the sysmon log and found the MD5 hash of that file. And the action on their objective was to deface the website. That's basically what they were trying to do. So we examined the logs, and we found the file name that was used to deface the web server. And then on the weaponization phase, the domain that was used, the C2 server, the online, kind of like a public C2 server that a lot of people could use, I guess, was this thing at Jumping Crab. So the IP address was exactly what we had found already, and there were multiple masquerading domains associated with that, and the email of the person who owned those domains, the Wayne Corp domains, was lillian.rose at Poison Ivy, which was associated with the attacker's IP address. And so then in their delivery phase, we used online threat intelligence sites to find the malware that was associated with their IP address, which was a secondary attack vector if their initial compromise failed. And the malware name was Miranda Tate's screensaver.scr.exe that had the MD5 hash right here. And that is a basic overview, like a really quick overview of everything that we found through this exercise right here, which again I thought it was actually an awesome exercise. So hopefully you also learned a lot of things from this exercise as well. If you did indeed learn from this exercise and from this video, I think this is going to be a pretty nice sized video. I think we went at least easily over an hour covering all of these things, and we were able to learn some really good queries, and we were able to learn some really good tactics to find information and reverse engineer the process. We used OSINT sources as well as all this stuff that was available on Splunk. So if you learned anything from here, if you got any value from this video, or if you've gotten any value from my channel, I invite you and humbly request that you like and subscribe and turn on the notification bell, and even drop a comment, because all of those things help the YouTube algorithm to find our channel, and from there we can expand and grow the community, get a little bit more reach, and try to help other people like you who are trying to learn about cybersecurity and penetration testing, ethical hacking, all of that good stuff. And as a secondary and maybe even more important benefit that comes out of that is that if you actually subscribe and turn on the notification bell, you'll get more videos like this, and you'll learn more things about really important tools that are actually used in cybersecurity analysis and pen testing and ethical hacking, all that stuff. It directly applies to your path if you're trying to become a security analyst or penetration tester, ethical hacker, so on and so forth. So it's a win-win situation, in my opinion. You get something and I get something. And the one thing that I'm really trying to get is literally just to grow the channel. I'm not asking for any money or nothing like that. It's just trying to get more reach so that we can grow the community and help more people. And that's really all I can ask for. And in exchange, I will keep dropping more videos for you on the daily, and sometimes even multiple times a day. So like, subscribe, turn on the notification bell, drop a comment, all that good stuff, so that you can join our community and become one of our beloved hackers that we are trying to train and help grow, and so on and so forth. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And we just wrapped our incident handling with Splunk room. So I hope you got value out of it. If no one else loves you, Hank loves you. Peace, love, and chicken grease. And I will see you in the next video. Later. All right. Hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers. And in today's video, we are going through investigating with Splunk, which is basically a challenge. And this is part of the pathway for TryHackMe for information and event management. So security information and event management, which is SIEMs. This is actually what the pathway, oh well, nope, it just took me automatically in here. But what the pathway looks like, and I'll just drag and drop this over here, is like this. So this is the security information and event management. This is inside of the SOC Level 1 pathway of TryHackMe, and we're in the SIEM module right now. And we are doing this particular piece, which is investigating with Splunk, which is this series of questions right here. And yeah, without further ado, we're just going to jump into it. If you would like to get more videos like this along the SOC Level 1 pathway for security analyst or pen test plus or ethical hacker, any of that stuff, please subscribe and turn on the notification bell and like, and maybe even drop a comment Two things happen when you do that. Number one, it actually helps the YouTube algorithm find our channel so that we can help more people like you and grow the community, and it just helps us actually move forward and help more people. But the second and more important thing is that when you actually subscribe and turn on the notification, you actually get notified the next time that a video comes out. And I have done videos on all of these things already. I've done videos on endpoint security monitoring. All this stuff is on the channel. Network security and traffic analysis, all of this stuff is on the channel. So if you subscribe and turn on the notification bell, you'll actually get notified when these videos come out, and it'll help you in your path of becoming a security analyst, ethical hacker, penetration tester, so on and so forth. And in my opinion, it's a win-win situation. So without further ado, let us jump into the challenge of this room. Okay, so this room actually requires that we start the virtual machine, which ends up being the Splunk server. It takes about 3 to 5 minutes to start. And then you also need to deploy the attack box, which is the blue button that comes up here. And then when you do split view, it gives you the option to go full screen. And when you go full screen, this is what it looks like. It opens up the Ubuntu Linux machine, which is here. And then you just go into the Firefox browser and you go into the IP address that they give you. The 10.10.241.43 is what I got for this instance. So I got this specific IP address right here. And from there, it takes about 3 to 5 minutes for that machine to actually load, for the virtual machine to actually load with Splunk, the Splunk server. And once you have that, then you can go into the web browser, go to that specific IP, and it'll bring you into this little dashboard right here. And in this particular case, I believe this has already been loaded for us. So the first thing that we need to do is just go to the search and reporting so we can see what specific log file has been created, what index we're looking at, and so on and so forth. So just looking at the search history right here, it seems that index main, and they say that in the question, it said the first question is how many events were collected and ingested in the index main. So if I just click on this, I can either copy and paste it, or I can just do add to search right here, and it'll add it, and I can do all time and do a search just so we can see how many are in here. And it says 12,256 events. So let's see if that is the right answer, because we haven't gotten any kind of a timeline for this. So it might not be the answer, or it might be the answer. Let's see if it actually is. And let's see. Okay, 12,256 is correct. So that's the first question. And I'll actually start answering them in this window so you can kind of see everything as we go along. So the first question was how many were collected and ingested in the index main. So that's 12,256. And it says on one of the infected hosts, the adversary was successful in creating a backdoor user. What is the new username? So the first thing that we got to do is we got to find first the infected host. And then from there, we'll kind of work our way backwards and try to find the new username of the infected user. And the hint gives us narrow down based on the event ID. So let's see. Okay, doing a simple Google search for the event ID for a new backdoor user brought this thing up where it says, what is ID 4720? And it says when a user account is created in Active Directory, the event ID 4720 is logged. So we're going to actually go to our events right here, and we're going to look for the 4720 event ID to see if anything comes up with that. And with that event ID, with 4720, there is just one event that shows up out of all of our events. And there's a lot of detailed information that comes from this. And what we're trying to find is the username, the new created username for this, so we can see what it was. And there's a SAM account name right here, which is Alberto. And there's the subject username, which is James. And if we try to go a little bit further and see what else we can find, we'll probably find the information. So it seems to be that Alberto is the new account that's been created, and it was done under the log ID, or the login ID for James. So let's see if there's any other information that we can find, but I think it's Alberto. So let me just double check and make sure. All right, we're going to go look at Alberto. Oh, you know what? It's not Alberto, it's A1Berto. So it's not AL. It's actually A1Berto. I got it. A1Berto. There we go. That's how you spell Alberto. That's a little tricky. Okay, so now on the same host, a registry key was also updated regarding the new backdoor user. What is the full path of the registry key? Okay, so here's another Google. So what is the event ID for a registry key? And so event ID 12 represents the creation and deletion of registry keys and values. So we're going to change our event ID to number 12 here, and we're going to update our search a little bit. We even have, I think we can even narrow it down to the host name, because that would probably make it a little bit useful too. So we have a host name here called Michael Bevan. So to kind of make this a little bit more of a fine-tuned search, we're going to do host name equals Michael Bevan. It's already one of these options, so voila. And then we're also going to do the Alberto in here just in case. And so now we have two events over here. And let's see if we can find a registry key. And a registry key looks just like this, actually. So this is exactly what a registry key looks like. So HKLM stands for the local machine. And then we have SAM, domains, account user, username, Alberto. So this is it. So there could also be HKCU, which is for the current user. But this is done on the local machine. So this is probably going to be our registry key. And I'm going to copy this. And I'm going to go here and I'm going to paste it, and hopefully that'll be the right. Great. So that is the right answer. Now the next one, examine the logs and identify the user that the adversary was trying to impersonate. So let's see who we can find that the adversary is trying to impersonate. So just from the fact that it was Alberto with a 1 in there instead of an L, I'm going to venture a guess that they're trying to impersonate Alberto. That's why they did that. But we can just kind of verify. There's something called the users. There you go. We have users here. And then look at that. So there's actually a user named Alberto under our user values. And this one is kind of a quick one to find. But you could also just guess it a little bit. You can take a guess that if they try to make something that looks like Alberto, but they replace the L with a 1, they're probably trying to impersonate somebody named Alberto. So if we did that, that should, yeah, there you go. That is the right answer. So now it says, what is the command that was used to add a backdoor user from a remote computer? So we're going to go back down the path of that adding the backdoor user and trying to find the actual command that they used to add the backdoor user from a remote computer. So this one is a little bit tricky because it could have been that first event ID, but there's the event ID for a new process that's been created, which is 4688. And we could just go back to that first event ID to see what we got. And so 4720, I'm just curious if that's actually the case, but it only brings one thing. And then in here, there's really no command that we can kind of find. So a new process created might be the other one. So we can do 4688 to see what the command is that shows up. And there's 25 various items that come through here. And so there's something right here, right? So command line, C Windows, SVC host, K, and medic service. I don't know if that specifically applies. We can try to kind of scroll through this just to see if we can find any other commands that have been run that might resemble one that creates a user. We have a value, an interesting field that has been pre-populated for us. And inside of this interesting set of fields, we have a few that kind of look interesting. And then there's one that just is super obvious that says, create net user add Alberto with that password. So this is the full command. I wonder if I need the full thing, but let me see if I could just copy the value of this. Maybe just copy the link. Or if I actually, so if I click it, it should probably just open it up for us. That could be the command that's run. And that's it. So this is the full command right here. So we're just going to take this entire thing right here. And easy to copy. So we're going to copy that. and then we're going to go here and we're going to type that in there or paste that in there. Sorry about the background noise. It's kind of a busy night here in Los Angeles, so I'm giving my location away to you guys. It's also super rainy out here. I don't know if you guys have been keeping up with the news out in California, but apparently there is a new technology that they're testing with the government to launch seed clouds, basically rain clouds, to create more rain patterns, because California is like a drought state, like a no rain state. So for the last 5, 6, 7 days from the creation of this video, there's been so many freaking rainy days, like just pouring rain. San Diego was flooded, a lot of crazy stuff. So it's a busy day, busy time of the day. So I do apologize for the noise. I will try to cut out as much of the noise as I possibly can. So let's move into the next one, which is how many times was the login attempt from the backdoor user observed during the investigation? So now we want to see how many times the login attempt from the backdoor was done during this investigation. And just going back to our search being the index main and searching for Alberto, the modified Alberto, not the actual AL. This is the A1BERTO. We have some categories and we have activity IDs over here. The activity IDs don't really help us. We have some categories here, which is process creation, registry object added, account management, executing pipeline, registry value set. We can try to see if there was any login attempts made over here. There was the creation of the thing, added the event, net user add Alberto, so on and so forth, but it doesn't seem like there was any login attempts. There is registry created. Let's see if we can find anything else. It doesn't seem like there was a login attempt. So maybe, okay, yeah, so there is no login attempt. They just created the username and password. And what is the name of the infected host on which the suspicious PowerShell commands were executed? And so we have that already. We saw that earlier. It was right here. I think it's Michael Bevan, which is the infected host. So let's see if it is Michael Bevan. I don't think it's Michael Bevan. Huh. Doesn't look like it. Let's see. So there is one little hint from here that we can actually use to try to narrow this down, which is PowerShell. So if we go up here and search for PowerShell as our potential search item, we have 198, and then we can go to host names and see what we can see. And there's one host name right here. So James Brown, that is our guy. James Brown, there he is. Now PowerShell logging is enabled on this device. How many events were logged for the malicious PowerShell execution? So let's see the events that were logged for malicious PowerShell execution, and for that we can go and try to find an event ID for it. So let's see what we can find. Okay, so when we look at event IDs for PowerShell execution, there's one that's 4104, and this is just PowerShell execution, contains a user who executed the script, so on and so forth. Content of the script might not appear suspicious. If you look at the details for the event, you can see the intent. The event ID is 4104, and then there's another one down here that allows you to identify possible misuse or unauthorized activity. This might be interesting. Track the usage of PowerShell commands and inspect the issues or errors that might crop up during the execution. So it could be 4103 or it could be 4104. So if we do event ID equals 4104, see if anything comes up. Nothing comes up. What if I delete PowerShell and just do the event ID 4104? Nothing comes up for that. So what if we did 4103? We do have that. And so let me do PowerShell one more time and see what shows up. So 79 events show up here. Let's see if that's the right answer. That is the right answer. Okay, so 79 events showed up when we searched for the event ID 4103 as well as the word PowerShell. I think without PowerShell, it might even be the same, the number of events. Yeah, it's 79 events even without the word PowerShell. So 79 events. And then it says an encoded PowerShell script from the infected host initiated a web request. What is the full URL of the PowerShell? So in fact, an encoded PowerShell script from the infected host initiated a web request. So what's the web request? Defang the URL. CyberChef can help with this. So we got to defang the URL, and we're looking for an infected host, or encoded. My bad. An encoded host. So let's see what we can find here. It's a web address. Obviously, we're looking for a web address. So this is actually, I think this is it, because this, I mean, this looks like an encoding. ENC right here also implies encoding. We can see that they're running a PowerShell command. This seems to be a very long thing right here. So how do I even get this whole piece from here? It's a very, very long piece. So this is kind of interesting. And then we're going to try to see, wow, look at this, man. How do I even, how can I kind of speed this up and go to the end right here? Let's see if I can find the end of this. It's a very long field. That seems to be the full-on encoded version of this. Let me see if I could drag this. There we go. There's a little drag right here. Take this all the way to the end. And that is the full thing. Holy cow. Look at that. So I'm going to do that. And then I'm just going to go to the beginning and hold down Shift. And hopefully I can highlight this whole thing. Oh, gosh. Or you know what, this might be the better way to do it. Let's just bring it, yeah, we can do this. So we'll highlight from the beginning and just kind of bring our cursor down a little bit, and we'll have this whole thing. And now I can go here and go to CyberChef, and from CyberChef, what I need to do is put this as my input. Oh my God, look at that. And what do I need to do? I need to URL decode first, I think. So bake that. And nothing comes out of that. So there needs to be a better way to do this. I don't know exactly. I gotta do a little bit of research to see how to to look at this whole thing. This is insane. You can do that. Let's see. Okay, so this I would not have figured out without some some research. And so we're using two different decode, or two different kind of like CyberChef option. One of them is a base 64, which is basically what this kind of is. It's just a bunch of binary code, or ones and zero type code, and then we're decoding text because it's literally just text, and then it has a bunch of different decoding options. And the first one I think was UTF-8, that was just pre-selected, and then when I made it down to 16LE 1200, which is it's the third option. When you click on this thing, it's the third option. We actually get some kind of legible text here. And can I zoom in here? I can. And so there's something right here where it says from base 64 string, and then we have this piece that it goes right here, this piece right here. So if we copy this one, and let's see if that does anything for us. So now I'm gonna paste that. Oh, I forgot to properly copy it. Let me try this one more time. Oh, look at that. Yes, excellent. So now we actually have some kind of a URL here. And so now I'm just going to do defang URL. Defang URL. And there's what this looks like. So maybe this might be the answer. Hopefully that's the actual answer. Oh, it's missing something. It's missing something after the fact, because it's the defanged URL, but then there's also something else that is missing here. So I wonder what we're missing. Okay, so we went back to the original block of text, and we're looking at this string right here, and there seems to be there's this right here. that could be a little addition to the end of that. So if I copy this, or I'll just /news.php. So I'll just remember that /news.php. And I'm just going to take this one more time. We're going to take this one more time. We're going to copy this and we're going to delete this, paste that. That's going to be it. And then we're going to do /. Oh, I think do I need to manually do it? So maybe it'll just be this, which is what we have already here. So what if do news.php? Is that it? No, I think the .php also needs to be defanged. So like that. Yeah, there you go. Okay. All right. That is not bad at all. That was pretty okay. So one of the things that I'm learning is that there is an event ID attached to pretty much all the events. And so if you just do some Googling to try to figure out what event ID might be close to what you're looking for, it's not that hard to hunt these things down. And then there's a lot of interesting fields, right? So when you go, when you search for whatever, there's the interesting fields that are just kind of pulled out from Splunk that might be useful for you to look at. And there's a lot of good things that could actually fall into it that might actually be useful for us. So for example, I think for this last one, we were trying to find the host name. And so it just pulled it for us. And so there's an interesting field called, host name James Brown. And so just kind of finding the event ID that resembles what you're trying to find, or go and Google, backdoor attempt or a PowerShell command that might be suspicious or something like that. And those types of things end up helping you narrow down what event ID you're looking for. And then from there, you have more zoomed in of a search query, and then you can kind of take it from there. So that was pretty much it for our Splunk investigation. So I'm very, very excited about this. And here we are. We officially made it, and we were able to answer the questions for the investigating with Splunk task, or mission, or whatever, challenge. Let's call it a challenge. So that's it for this one. All right, so if you found this video useful, or if you learned some cool little tricks from what we just did right now, then I welcome you to like, subscribe, turn on notification bell, and drop a comment. Let me know what you learned, and let me know if you have any questions, or if you just want to say hi. All of those things help us tremendously with the YouTube algorithm and to get a little bit more reach on this channel, so that we can go ahead and expand the community and help more people just like you who want to learn about cybersecurity and ethical hacking and security analysis and penetration testing, all that good stuff. And then there's the secondary, which is probably the more important benefit, which is you will actually get notified the next time a video comes out, and you'll kind of be able to pursue down your pathway, whichever your pathway is, whether you're studying SciSec or pen testing or whatever it is. This will actually help you not only in your studies, but in just developing your skill set to become a better security professional. So it's a win-win situation for the both of us, and I would just love to have you as a part of the community. It would be amazing to have you join the gang. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And this was the Investigating with Splunk room, the challenge that we just did through TryHackMe. I hope you learned something. If no one else loves you, Hank loves you. Peace, love, and chicken grease. And I will see you in the next room later. All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And in today's video, we are going through the Benign challenge. This is a part of the security information and event management module of the SOC Level 1 pathway in TryHackMe. And we have done all of these tasks, and there's videos on all of these tasks, or all of these rooms, I guess. And now we're going into the last one, which is the Benign challenge, which means that there is a compromised host that we're trying to essentially uncompromise. And yeah, that's kind of the task of the day, the mission of the day. Before we jump into this challenge, I invite you to like, subscribe, and turn on the notification bell so that you get notified the next time a video comes out. And even if you could drop a comment, all of those things actually help the YouTube algorithm to find our channel and to help more people just like yourself who are trying to learn about ethical hacking and cybersecurity and penetration testing. And as an extra benefit, which probably is the primary benefit, you'll actually get notified the next time a video comes out. And if you're studying for any of those paths, then all of these videos will actually be helpful to you. Things like using Splunk to do investigations and, fix compromised hosts, so on and so forth. All of these actually directly apply to the examinations that you would take for CompTIA CYSA Plus or the Pentest Plus or the job that you would do as a security analyst. So it would be a win-win situation in my humble opinion. Without further ado, let's jump into the introduction isn't really anything crazy. You just need to make sure that you start the Splunk server. It takes about 3 to 5 minutes to start up, and you all need to start the attack box as well, which is the blue button in the corner. And then when you do that, the thing starts up and you can get access to it via the browser of the attack box. So in this case, it's the Firefox browser, and so this is what the browser actually looks like. And this is what we're here. This is the dashboard of Splunk. And the scenario is like this. So it says one of the client's IDS, intrusion detection systems, indicated a potentially suspicious process execution, indicating one of the hosts from the HR department was compromised. Some tools related to the network information gathering scheduled tasks were executed, which confirmed the suspicions. Due to limited resources, we could only pull the process execution logs with the event ID 4688 and ingested them into Splunk with the index win event logs for further investigation. What we know about the network is that this is the IT department, the HR department, and the marketing department. And we're just gonna kind of get into answering these questions. So the very first one is asking us how many logs are ingested for the month of March 2022. And so we're just gonna run it basically. So we need to go into the index for win event logs and then look at March 2022. So you go into Splunk right here for the search, and then we can go into index equals win and then event logs. It's right there. So we're gonna do that and just press this timer right here, and then we can go to date range at the bottom, and then we can actually verify what we want. So we want between February and March of 2022. So I'll just do this. I'll do 03/01/2022, and then I'll come all the way over here and we will do 03/31, I think is how many days are in March, right? Yeah, okay, great. And whoops, there's that. And we're gonna apply this. And so now we got that, and then we're going to search. And just like that, we have our logs. And just for the March of 2022, there were 13,959 events. So that's the first answer. The next one is the imposter alert. So there seems to be an imposter account observed in the logs. What is the name of the user? And if you remember from the last one that we saw, an imposter account is essentially going to look like any of these guys, but there's probably going to be a letter that's different and so on and so forth. So we got to try to find what the user IDs or the imposter accounts might look like. So let's see what we can find in our interesting fields here. Okay, so straight from the get, you can see that we're supposed to have a Diana. And then when we go and look at the usernames right here, there's somebody called Dana. And so Dana doesn't seem to be the correct spelling. So I'm just going to say that it's Dana who is the imposter account. Or, well, so let's see. Diana. Huh. Okay, maybe not. Okay, so if we do a quick little search by username, and we just create for the table username and then the dedup, and I just found this on Google. I think it just helps to get the organization of this. So what it does, it brings the statistics up for us. And Dana, although it is misspelled, is not as bad as Amelia, with the number 1 instead of the I right here. So in this case, it's probably Amelia. So if we just go here and do AMEL and then the number 1 A, that's going to be our imposter. Okay, so from here, it says which user from the HR department was observed to be running scheduled tasks. So now we're going to go and look at that. So now we're going to try to find that out. And so we can go back and do a little thing right here. And then just from the get, we want to find running scheduled tasks. So we can look at the command line potentially. The event ID is all going to be the same, so that's not going to change. But we do want to find something that has to do with running scheduled tasks. So let's see what we can find here. So the first step in that part of the search is going to be searching for just scheduled tasks inside our index, and it brings up 87 events. And then we have the username field, and there are 4 usernames that show up in here. We have James, Moyne, Katrina, and Chris Fort. Chris Fort has ran it once, and the command line is create an office updater for Chris and see on start. And then so if we just change that, so if we go back and try to find what the other types of commands may have been that were run by the other users, we can try to kind of narrow it down. Although I feel like it is Chris Fort already. And then we can just see what's going on over here. And there's now 4 command lines for, what is it, Katrina. And so query list, delete something, and then change something. And then the first one, there is no value for the command line, so there's no command line execution, and that was Katrina. And then what we can do is go back one more time and look at Moyne and see what the command line for Moyne was. Which is the enables, so automatic updates, query and deletion, and then we can do the last one that was, I think, James. And if we look at James's command line executions, it'll be a change that was enabled on automatic updates, query, and then delete. So the only person that actually had a start was Chris Fort. So if we click on this one more time and go to Chris Fort, we can see that he only ran one command, but the command was create office updater, yada, 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 and then start, on start. And so if that's the thing right here, and we have the command line right here, which he's creating something. So the other ones were like more updating things or deleting things or querying something. This is a new process that's been created, and it's being done on start. And so Chris Fort is most likely, and I think it is because they already kind of give us that hint on the syntax, like the format of the name. So now which user from the HR department executed a system process called lolbin to download a payload from a file sharing host? And it says explore lolbassproject.github.io to find binaries used to download payloads. So let's see if we can do a search for lolbin and see if anything comes out from that, and then we can just go search the GitHub for binaries. All right, so nothing comes up in lolbin for the search for lolbin. So now we can go to this particular GitHub and see if we can actually find something that would be relevant as far as binaries are concerned. And there is a lot of binaries here, buddy. So the specific binary that we're looking for to download a payload from a file sharing host. So let's see what we can do for downloading a payload from a file sharing host. Okay, so doing a simple search for download inside the page contents shows 46 results, and it could be really any of these. So it kind of takes a little bit of finessing to go through some of these things and I guess search for them one by one. So I will do some searching and see what we can find with any of these binaries here. All right, so now doing a search in our event logs. So the table command, I just verified. The table command just shows up as table version of all the results with whatever field you want to look at. So the process name, the command line executed, and the username. And then dedup actually removes the duplications. So D is delete, and then dup is for duplication. So delete any duplicate process names that would show up. And so now we have this little organized thing, which gives us about 178 results out of everything. And so I organized by the command line to just show everything that actually had a command line execution. And then just based on the results that I saw from the thing right here, there's one immediately towards the top that is called cert utility. And cert utility has been used to download things, and it can be used to download things. And then so now we have a command line right here that looks very, very suspicious if you kind of think about it. So they use cert util, the URL cache, and they downloaded it from this thing, and they saved it as benign.exe, so benign executable, and that's like a big hint right here. The name itself is probably going to be different for a lot of people, and then control C kind of could be control center maybe, or command and control, something like that. So there's a few hints inside this that makes it super suspicious. And then so we have cert utility that's been used to download. Benign itself just as a name, it's the room name, and a lot of things about it just seems suspicious. And the username for this is Haroon. So we're going to go and type in Haroon here, and we got it right there. So okay, to bypass the security controls, which system process from lolbin was used to download a payload from the internet? And I believe that's certutil.exe. And there we go. And what was the date that the binary was executed by the infected host? So now that we know that the username was Haroon and the executable was certutil, we can just search for that. And now we have the one event that ties to. And so there's the event time, which is our date. So it says 3/4/2022, so March 4th, 2022, and they want it to be 2022 03/04, like that. So there we go. Which third-party site was accessed to download the malicious payload? And from what I remember, it was controlc.com. And then what is the name of the file that was saved on our host machine? And that was benign executable. And the suspicious file downloaded from the C2 server contained malicious content with the pattern yada yada yada. So what is the pattern? So now we got to go and look at this suspicious file that was downloaded, which is actually the file at this thing. So we're going to go to this location and see what that file is. So let's see that. I could just do open link in new tab probably. You know, just open it up inside our thing right here. We just agree, that's fine. And nothing exists here. Okay. Okay, so the actual URL that they're referring to is the right answer. So I was able to actually paste this in here because they were asking as the last question, what's the URL that the infected host connected to? But when you go to this URL, it is a dead page because I think it was removed or something at some point. And so the answer for that part is no longer here. And the only way that I was able to find it is to actually just look up a previous write-up for this room for somebody who had already completed it to see if we can pull the flag. And that is indeed the case because it's literally the same thing right here. So they actually use the same URL that we just used. So all of this is all good. And it shows that the connection was made to this thing. So this is the flag that we're looking for. Unfortunately, this doesn't exist because when we go to that link, this is not the results that we get. So we don't get this as the link response. We only get it from somebody who had previously written it up. And I mean, you're literally seeing me go to the actual link itself. So this is kind of the challenge that we are dealing with at the moment. And that happens to be the only way that we can actually pull this answer. So the issue, excuse me, the issue in this particular case is that that link is a dead link. So if this happens to you, where you're trying to go to the specific link that's inside the URL, because there's only one execution here that uses cert utility to download something from the URL. That's the only URL. There's no other information that we have on this apart from that URL. So even if when you look at the raw text version of this, it also doesn't give us anything apart from this URL. So that's the only way that I was able to find the information for the flag, unfortunately. So just in case you're running across it and you can't find the answer, and you're going, you're bashing your head against the wall, which is what I did for a few minutes here. That's actually how you find the answer. So that's pretty much it. And just like that, we were able to finish the Benign challenge for Splunk. And we are now one of the people who actually ended up completing the room. So it should be pretty exciting to go through. And now we have access to the finished lab right here. So there you go. And just like that, the room is wrapped. And if you learned anything from this, if you took away any takeaways or any answers, or if it helped you go through this room, or if it helped you learn from Splunk, so on and so forth, please go ahead and like, subscribe, turn on notification bell, and drop a comment. When you do those things, two things happen. Number one, you help the Google, well, Google owns YouTube, so that kind of works. But the Google and YouTube algorithm, they give us our channel a little bit more reach, and it actually helps us to expand the community and help other people just like yourself who are studying cybersecurity and pen testing and ethical hacking. But the more important thing is that when you subscribe and turn on the notification, you actually get notified the next time a video comes out. And if you're studying for any of this stuff, then all of these things are applicable to your studies as well as your day-to-day job as a security analyst, incident response person, pen tester, so on and so forth. So it's a win-win situation if there ever was one. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker, and we just wrapped the Benign room. I feel like this is kind of annoying that everybody else who finished this room only got 300 points, and whoever this person is up here ended up getting 800 points. So I don't know why that is that they got 800 points. I am kind of upset about it. I want to know who it was and why they got so many points. I almost have a the urge to write TryHackMe and be like, what the hell, you guys? But anyways, we wrapped the room, and I hope you learned from it. Peace, love, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next room. Later.